अभी भी मैनुअली काम करते हैं और हाथ कैलकुलेटर की बजाय अपनी उंगलियों से ही काउंटिंग भी करते हैं। तो बहुत अच्छी बात है कि आप लोगों का फ्यूचर ज्यादा ब्राइट है। आपके लिए कोई और सोचेगा भी और कोई दिमाग का भी इस्तेमाल करेगा, लेकिन मैं समझती हूँ कि ये जो आर्टिफिशियल इंटेलिजेंस है, ये आर्टिफिशियल इंटेलिजेंस ही बनी रहे और उस इंटेलिजेंस को बनाने वाला ह्यूमन माइंड ही रहे। यही जो है हमारे लिए बहुत ही खुशी की बात होगी। तो थैंक यू वेरी मच और बहुत बहुत आप लोगों को शुभकामनाएं कि आपकी ये कॉन्फ्रेंस सक्सेसफुल हो। थैंक यू वेरी मच।
Thank you, ma'am, for your wise words. Life is a series of experiences. Each of those makes us bigger and stronger. Perhaps it is hard to realize those. The world has been built to develop character, and through experiences, we must learn from the setbacks which help us to succeed. I would now take the pleasure to welcome Dr. Rajiv Shore, the chief guest of the day. Dr. Shore is the CEO of the University of Queensland, IIT Delhi Academy of Research. Dr. Shore also serves as an adjunct faculty in the Computer Science and Engineering Department at IIT Delhi. He received his PhD and MS in Electrical Communication Engineering from the Indian Institute of Science, Bangalore in 1997 and 1991 respectively. He received his bachelor's degree in computer science and engineering from IISc Bangalore in 1987. Dr. Shore's career spans several reputed research labs: TCS Research and Innovation, General Motors India Science Laboratory, IBM India Research Laboratory, and Sustain Technologies. Dr. Shore served as the first president of an IIT university from 2009 to 2013 before joining the TCS Research Labs in 2014. Dr. Shore's work has resulted in more than 70 publications in international journals and conferences and several US patents, all in the area of wireless and wired networks. He has 12 issued US patents and several pending US patents to his credit. Dr. Shore serves on the editorial boards of two of the top journals in the area, IEEE Internet of Things and Springer's Journal of Wireless Networks. His areas of interest are wireless networks, including 5G networks, telematics, IoT, industrial IoT, IoT security, and automotive networks, including automotive cybersecurity. For his contributions in the area of communication networks, Dr. Shore has elected a fellow of the Indian National Academy of Engineering in 2007. Dr. Shore was recognized by ACM as a distinguished scientist in December 2014. He is a fellow of the Institution of Electronics and Telecommunication Engineers, India, and a senior member of IEEE. It is my pleasure to invite the chief guest, Dr. Rajiv Shore, to share his knowledge and expertise on the topic recent investigations in AI, machine learning, and edge computing.
Slides? You have my slides? Yeah. Good morning, everyone. Namaskar. I really liked what the Professor Sharma, what she said earlier. It's a great pleasure and a privilege to be here. First time at the Shyama Prasad Mukherjee College for Women. First time. So this is the first time in this college. I've been in this area many times, but again, an added pleasure and a privilege to be over here. Let me start by thanking the team here, the organizing committee, of course, the respected principal, Professor Sharma. I know that all of you, with under the leadership of Professor Sharma, have spent have spent a tremendous amount of energy and time and efforts in taking the college to great heights, and that's where we see now. I believe there are 4,000 plus students in the college now. I think the credit goes to the leadership team. And again, congratulations to all of you here. I also heard this morning that the college has crossed 50 years. That is indeed a milestone, and you know, no mean achievement. So with that, congratulations once again to all the members in the college, the students, of course, and the members of the staff and honorable principal. I think, so as I said, you know, I'm delighted to be here today. And when they said I'm the chief guest, I said, look, I don't know about that, but I certainly would love to give a talk, because I do give talks to students all over the globe, whether it's United States or Europe or all over the country. And so this will be a talk. This is something that I would love to do, is give a talk and take you through the journey of machine learning and artificial intelligence, and share with you our experiences, our journey all over, you know, wherever we worked. And today, what are the important areas in the, you know, in the theme that is that we're discussing here. I'm also very delighted that UGC has sponsored this whole theme of AI, the next generation of computing. It is indeed a very critical area. And during the course of my talk, I will have the pleasure of sharing with you some interesting insights, not just facts that all of you can get, but some insights of experiences in working with AI and machine learning. And I hope that you will, you know, hope to take you through this journey along with all of you. I'm planning to give a 45-minute talk, because I was telling my colleagues over here before this, you know, before we entered the room, that I love to have Q&A from the students and from the participants in the seminar. So for those of you who really, I mean, please, I strongly encourage questions. That's exactly what I tell my IIT Delhi students. I work with some of the sharpest 20 BTech students of IIT Delhi, probably the top 100 JEE rankers. And I tell them, look, please ask questions, because without question, you know, either you understood everything or you understood nothing. Now, if you understood everything, then I'm delighted, but I'm a little bit overwhelmed. If you understood nothing, then that's a disaster, right? So please ask questions and make it a more meaningful and a fruitful, you know, event of this very interesting seminar. So I'm going to start with sharing with you my thoughts and my, you know, as I said, my experiences in the journey of machine learning and AI. So I'm going to request the team to open this up. Great. So I'm all set now with my slides. Okay, so I'm going to talk about the recent investigation in AI and machine learning, and take you through what's the. And I think one of the important points that I like to cover is what are the hot research topics in the area. Because, you know, as many of you are embarking your career, you're going to be working in a few years from now, or you probably will be looking at this topic in your career as an academic or as somebody in industry. And so it's very important to understand what is the current trend and what are the developments and what are the open research areas. और सबसे बड़ा challenge ये होता है that, you know, it's very hard. So one of the things we learned in the last few decades of our as a researcher, you know, if you tell a student, if you define the problem, a sharp student like all of you can always solve the problem. But the hardest thing for an academic, and I'm sure that's true with every area, whether it's in commerce or arts or in sciences or engineering, to define a problem which is open and which is novel is very difficult. It's not easy. I mean, you won't believe it, even though aapke JEE ke toppers hain, you know, the people who are in top 50 in the country, and some of them are my students, they just cannot define the problem because they don't have the experience, they don't have the expertise. They may be great in the area, but one has to work with them and tell them, look, here are the problems, open research problems that you have in mind, and you can solve it, but, you know, I'll help you to take it through the end, right? So that's the most important thing. So let me take you through the journey of AI. I'm going to start my talk with the AI revolution and why is AI, ML, and now deep learning a very, very important area for all of us. I'm also going to, so I realized that let me start with some examples, right? No point going into technology straight away. So I'll start with some examples. And one of the examples I thought, and I was, you know, giving a lot of thought last few days, kaun sa example is shuru karu, which is going to excite the audience here. And I realized, let me take you through go deep into the smart car journey. You know, what is autonomous driving? what are smart cars and what are the future directions of autonomous driving and smart cars. And the reason is that so while he's fixing it, I'll probably walk around. Yeah, whatever better. I can walk around and be closer to audience. So, so the reason that I thought I'd pick up this example is because I've been fortunate to work in one of the largest car companies in the world, which is General Motors Research. And this was, go back 10 years ago, and so we were in Detroit and in Bangalore. And the hottest area that time was cybersecurity, and still a very hot area. So it turned out that this sector was one of the first sectors to really use machine learning and AI. And I'll give you an example of where they use machine learning and AI. So आपकी सारी जो autonomous driving है, जो smart cars हैं, it's nothing but machine learning inside the car and at the back end. And I'll give you some concrete examples, right? So I'll give you an example, and then I'll come to how are computing and communication systems evolving. So for those in computer science, and I'm sure most of you are in WSCS, what are the key, what is the trend in this computing and communication? What are the new paradigms where we need to apply machine learning and AI, right? And then I will hopefully convince you that we have now reached the era of autonomous and cognitive systems. So today, every company is working on either autonomous or some of them call it cognitive systems. What is cognitive system, right? So we take a look at that. And of course, the most important thing is I look at the research challenges, future trends, and concluding remarks. And when I conclude my talk, I also want to, on a note of caution to all of us, with all the excitement that we have in technology, we are all technology folks. Our whole career is run in technology, right? And working with the best minds from all over the globe. But it does that. At the back of the mind, there's a fear. You know what the fear is? The fear is, where are we getting to? I mean, every child today has a stupid cell phone. I'm sorry to say that. That cell phone has ruined your thinking. People have stopped thinking. They don't use their brains. Students just kind of go on the internet and download stuff. Nothing wrong in it. But I keep telling my, whether it's my own daughters, they're studying, or whether it's my students, where are you using your brains? Where are you challenging yourself? That's one drawback of where we are today. The other thing is, what's the future? I got some autonomous kar denge. Look at the plethora of problems, cybersecurity. Systems that are completely autonomous are dangerous. So my favorite example to the folks, including my colleagues, is, and I ask this question to all those working in machine learning and AI, will you ever, if I ask you a question, will you ever fly an aircraft, let's say from Delhi to San Francisco, whatever, Delta Airlines or Air India, will you ever fly an aircraft when you are told to pilot to hey, it's all autonomous, it's all self-driving? I will never in my life fly that aircraft. I'm sorry. It may be the smartest ML, deep learning, all kinds of algorithms, but if there is no pilot navigating the aircraft, in my life will not fly. Maybe you will, but I will not. Right? And I'm telling you, if I ask you here, 99.9% will say no, you will not. We don't trust these algorithms. I mean, you trust them, but I mean, safety is an important issue, right? So how do you guarantee that? There are no guarantees in today's world. So it's a dangerous world there, and I'll give you some examples of that. Okay, let me start my talk and go straight to technology, and I will open up for questions. Now, if you have any questions between the raise your hands, I'll be happy to take it. But I will leave 15 minutes to the end for Q&A. So, but if you have any questions, please raise your hand. I really enjoyed the questions from students. Okay? So we are in an advanced computing. I mean, look at the paradigm in advanced computing, right? I mean, today we work on 5G, and now when I talk to colleagues from IIT Madras, ISC Bangalore, of course, IIT Delhi, all over IIT Kanpur, now they're saying 5G to ho raha hai, 6G ki baat karta. I mean, what 6G? Well, 6G is machine learning and AI and 5G. Okay, so now we're talking about 6G. India with 5G abhi aaya hi hai. It's just started. I must say that China, our rival, is way ahead of 5G. So we're not doing fairly well in 5G now, right? The last few months. Then, of course, 5G includes IoT. All of you know what Internet of Things is. So everything is IoT. I mean, what this device is like an IoT, it's like sensor and actuator, right? It talks to the access point. So all the devices, tiny devices that we have around us are IoT devices, provided they're connected to the cyber world. They're connected to the internet. They have an IP address. So they're Internet of Things, right? They're sensors and actuators. They combine the physical world with the cyber world. That's IoT, right? Then, of course, you have edge and cloud. Edge is becoming a very important topic of research today. In fact, most of my work now, the last years, was on edge computing. And I'll tell you why. Because machine learning and AI on edge is becoming a very hot area. But now you may say, edge, what is so big about edge? I'll come to why edge is very important. Cloud, of course, is there. I mean, all our data is in the cloud, whether it's Amazon Web Services or Google Cloud or Microsoft Azure or any other cloud. But cloud doesn't do that. It's very far. So to retrieve data from the cloud, my delays, my latencies can be very large. Okay, my delays, we call them latency, they can be very large. So I want to give data closer to me as an IoT device. I want to keep data closer to my laptop or cell phone. And that closer servers are called edge servers. They're closer to me. So they're somewhere in between the cloud and the IoT. So edge is becoming important, and I'll give some examples of what you do with the edge and why edge is becoming so critical. And then, of course, cognitive autonomous systems. Quantum computing is becoming is taken off big time. Neurocomputing is taken off big time. And so when you look at all these trends, computing paradigms, you ask the question, where are we heading to? What will happen 10 years from now? So when people ask me a question, Rajiv, what's going to happen 10 years from now? I don't answer that question. You know why? I'm not a politician. I don't want to lie. Right? I mean, not that they lie, but I'm saying I don't want to say things which are not proven. If they ask me what happens 5 years from now, I don't have an answer for that. But I can tell you what will happen 2 years from now. Anyone who can tell you what will happen 10 years from now is a quack. Be careful. Be careful. The person is dangerous. Keep away from people. Nobody can predict what will happen 10 years from now. All I can say is there'll be humanoids, there'll be robots, there'll be robots running all over, and they'll be thinking like us and collaborating and driving cars and airplanes and whatever, if you will. But I don't know. I mean, it's hard to say what the technology fuel comes like. Okay? So let's start with the example of autonomous smart driving. And this is a great example to convince all of you that indeed you need AI and machine learning, because without that, you really cannot make much progress. And it will be clear in the next 5 minutes. So now let me start by saying that the whole autonomous car market is huge. I'm not going to read all this. It's almost $1 trillion market, right? Tesla car, which has just come to India a short while ago. Tesla is one of the most important autonomous self-driving car in the US. And I had been fortunate to sit in Tesla and see Tesla all around the Bay Area. You know, that was the first car that really announced this is a self-driving car. I don't need a driver, right? So the area is expanding big time. Let's go deeper inside a car. Let's see what's inside a smart car. Now, what is a smart car, right? Aajkal sab kuch smart hai, right? Smart classrooms, smart buildings, smart offices. But my joke is that maybe we are becoming more dumber. So why don't we say dumb human beings and smart world? Truly, we are becoming more and more dumb. We are so, we rely so much on the devices, including that device right over there, that stupid cell phone, that we have lost our moorings, we've lost our reasoning power because we are so glued to all these technologies. But anyway, that's the part of life now, and we have to see how to come out of that. But if you look inside, so why a smart car? So smart car means that the car is completely driven by electronics, controls, and software. So we have a word for this. The acronym is called ECS, electronics, controls, and software. So inside any smart car, you have all electronics, mechanical to hair, mechanical after engine to mechanical hair, right? All your devices. Of course, there's mechanical engineering, but the mechanical engineering is working very closely with electrical circuits, electrical devices, right? That's running the car. And so there are flow controls over here. For those of you electrical engineering, control these closed loop control, right? I can control something and get a feedback and then make it better and better. Closed loop flow control. And of course, everything is software now. Did you know? I'm sure none of you, I don't think many would know this over here because it's me time to realize that if you look at one small component in the car, then I'll come to that component. Okay, I'll come to that in 2 minutes. But if you look at any small component called the ECU, and let's look at this box. It's called the electrical control unit, ECU. You know the software, the number of lines of code in that ECU? One ECU in one smart car. Any guesses how many lines of code? 100 million lines of code. 100 million lines of code in one ECU. And if there's one error in your code, and all of you have done C or Python or name it, Lisp or Prolog, If you make one error, then the program goes fucked, right? I mean, your system is gone, right? Now, will you ever fly an aircraft with no pilot? Right? One error. I make one software error. Buffer, array index out of bounds, or buffer overflow, or I miss a variable somewhere, or I kind of my pointers are messed up, and I'm saying, oh, this is a beautiful aircraft. It's completely automated. God bless you. Good luck. Right? So the smart card is really ECS, and inside a smart card you have tons and tons of sensors and actuators, but 100 odd sensors and actuators. There are sensors to measure the tire pressure. It's called TPM, tire pressure monitors, fuel gauge monitor for the GPS. There are all kinds of radars and lidars. Now, we don't have radars and lidars in cars in India, other than the top cars, because they're expensive. Up radar लगाओ गाड़ी में तो each radar is $100, right? Very expensive sector. And then you have lidar. Lidars क्या होता है? Laser based radar. Laser induced detection and ranging. Okay? So the laser beam is, as you know, it's line of sight. It's very strong beam, but it gives you great results if it's line of sight, right? So अगर मेरी गाड़ी के सामने एक कार है, पीछे कार है, साइड में कार है, I can clearly make out from the automation that look, this is the exact distance, and then get collision if I go faster or slower, because X, Y, Z and dot X dot Y dot Z dot coordinates are apparently clear, right? So the lidar and radars together with all these sensors make it a very smart car, and which is fully ECS, right? What are the key developments that change the world? I didn't know this till I really, apparently till I joined General Motors. Who knew? So suddenly one day we heard there's a network called OnStar system. Please go and look at onstar.com. So go home, look at onstar.com. So what does OnStar do? This idea, so sometimes ideas in the world are game-changing ideas, right? So my Cato students say, or my colleagues, if you really want to be successful, work on a killer idea, right? And you are done. You can fund Sham Mukherjee College for the next 50 years because you'll be earning $1 billion. That's why you have a killer idea, right? So the thing is that how do you arrive at the killer idea? This is one killer idea. What is the killer idea? The idea was, see, General Motors is a famous car company, right? All of you heard of GM cars, right? Very famous, the biggest company in the world. Suddenly GM को एक idea आया कि भाई देखो हमारी तो गाड़ियां दुनिया भर में है, right? ये काम होगा. And everybody has a cell phone. That stupid cell phone, right? Well, let me not use that word. That's a joke. But I'm just saying everybody has a cell phone and everybody has a car, right? Can I marry the world of cars and cell phone? How do I do that? Simple answer. Let me sign up. Let me collaborate with my service provider. So I'll have a partnership with my service provider. For example, Tata's may say, I want to partner with Airtel. Or Reliance Jio may say, I want to partner with Vodafone, right? That marriage is a killer marriage, because then what happens? Well, then wherever you go, thanks to the cellular channel, you can subscribe to services, and there are tons of services. So the first service OnStar way back, this is 15 years ago, right? OnStar defined automatic crash response. So they said if a car crashes, within seconds the police will come to the rescue because the message goes to the cellular channel. I'm partnering with my service provider, and the US provider is Verizon, right? So GM partnered with Verizon, and on that cellular channel, I could subscribe to tons of services. You can open the door remotely today. If you subscribe to OnStar, you can open the door remotely. Just call up the OnStar command center. Listen, my door is jammed. 1, 2, 3, click, the door opens. Can you imagine? You don't have to have the keys. You can close the door. You can start the engine today. Saying my engine doesn't start, I'm freezing. I'm under Alaska, which is minus 20 degrees Celsius. Please start my engine. 1, 2, 3, and the engine starts. Assuming that car is okay, right? My favorite service is stolen car detection. So अब वो दिन गए कि आपकी गाड़ी, बहुत, as you know, India when we have sound problems, cars are stolen. Not anymore. If you subscribe to services like OnStar, you know why? Just call up. The car is stolen, right? It's gone. So you call up the command center of OnStar and say, listen, my car is stolen. Please do something. They say, don't worry about it, sir. 1, 2, 3, and they send a jamming signal to the car. Wherever the car is, because आपका space station सब जगह है ना. There's actual space station all over. So you will send a jamming signal, the car will stop, and before you realize, the police is waiting. Come on, buddy, come to jail. So you can't even steal the cars now. India में अभी वो service नहीं है, but आने वाला, right? हम थोड़ा slow हैं, because हम लोग ना research ज़्यादा नहीं करते. हम लोग इतना we are so concerned about immediate returns, quarterly results. That India में research is taking a backseat. हो रही है, but it's really something we can do much better. Most of the research in India is American companies or European companies. And I wish Indian companies spend more time in research. Don't tell this to anyone. But I just wish. They do. Tata is my own company. They do spend a lot of money in research. But I can't even think of any other company. So they do. Right? I don't think they do. That's not coming. Okay, so Onsta was a game changer. And today you can do even diagnostics, prognostics, real time with Onsta. Then what happened in 2007, this is very interesting for the students over here, that one lesson we learned was that if you want to succeed in life and technology, the university must collaborate with industry. And I keep saying this to the leadership of every college university, myself from Iot, and I do that. Please partner with industry. And I tell the industry, partner with the college. Where will you get the best minds? Right? I mean, free mein milega mind, right? You don't have to pay to take interns from Shabbat College, right? So what happened was when General Motors partnered with Carnegie Mellon, this is a partnership with Carnegie Mellon that resulted in an autonomous race. So they participated in a race called the DARPA Grand Challenge. You can do go to the YouTube and you can just type on DARPA Grand Challenge, and you will see that many universities along with the industry participated in this race, and GM won the race because they partnered with Carnegie Mellon, right? So the best minds of CMU and GM came together and they won this race. This car is called the Boss, by the way, and I was a part of this. 2000, yeah, around that time. Not the full thing, but I was a part of the cybersecurity. Our team in Bangalore, one of the best teams in the world in cybersecurity. So we used to work with them, not directly but indirectly. And they won a race. So 60 miles in Southern California, completely driverless. There was no driver at all. This is 2007. So when you say the first cars, driverless cars at Google, no. Google just copied GM and Carnegie Mellon. Google wasn't the first. It came out from the labs of our companies and the university, right? And this car today, if you look at a driverless car, a smart car, it's completely, there are sensors and actuators all over. There are lidars and radars on all sides. But it's got machine learning and AI, telematics platform, and I'll cover it, right? So this is the car. Now where are we today? We have day of Tesla, right? Today, times of Tesla. So many of you would probably know Tesla is one of the first cars in the world, thanks to Elon Musk, which is completely, self-driving. It's autonomous, and yeah, of course there is a driver. You have a driver, but if it's sleepy behind the wheels, no problem. It will take you to the destination, provided you punch in your destination and your source, right? So it is completely a driverless car in that sense, right? Fully electronics controlled software, and Tesla is completely. There's so much of automation here thanks to again machine learning and AI. And let's take some examples in a few minutes, right? India mein abhi aayi Tesla. It's an expensive car. I think the starting value is about half of the road or whatever. So, but I think it's something that is will happen more and more. Because also electric car, right? It's an all-electric car, and you want to conserve your gas in today's time. So Tesla is a great example of something that was a research area, but now became a reality. Okay, now what else? What are the enabling technologies and services for smart autonomous driving? So let's go quickly into the sector. There are two aspects of of autonomous driving. One is inside the car. It's called in-vehicular network. Very complex. Inside a car, the network is very complex. And then there are networks between the cars. It's called V2V communication. X is because X could be V, X could be infrastructure, X could be pedestrians, right? So X could be anything. So that's why we have V2X. So cars can now communicate with each other using all broadcast wireless protocol. Why would they like to communicate with each other? Because they want safety of the passengers. I want safety on the highway. Agar aap India mein highways mein dekhiye, most accidents happen on there, right? Safety is the reason. So you want to have technology in the car, which is V2V, to provide passenger safety. That's the killer reason. Otherwise, why would business spend too much money on that, right? And inside the car, of course, you have all kinds of gadgets, and you have buses like Ethernet. Imagine whoever knew the Ethernet in the car, it's called the CAN bus, controller area network, right? And there are all kinds of sensors and actuators. They talk to the CAN bus, there are many CAN buses, and that bus talks to the platform, which sends a signal outside for the over-the-air interface. Just like your cell phone, where your software can be updated dynamically. Just the same way a car, you can have software which is coming from the back end, and the updates can happen dynamically. So it's a pretty interesting world out there, right? Yeah, I'm going to skip that again. Inside a car is very complex. There are all kinds of buses, and for each function, there is a ECU, electrical control unit, right? Okay, this is an example of V2V. As I said, vehicle communication. You want to avoid collisions, and so what happens is every vehicle broadcasts messages every 100 seconds, 100 milliseconds, not 100 seconds, 100 milliseconds, and the neighbors then hear the messages, and so they kind of they provide you safety because the messages carry some information over there, right? So all kinds of vehicular safety applications over there. Now we are talking about 5G in the car. So in future, you will have a very high bandwidth wireless pipe, we call it a pipe, right? For example, gigabit per second pipe. So there's 5G in the car or between the car and the base station, right? Because you may want to, you can have now conference calls in the car. Imagine 4 people in the car, all of them having audio, video conference calls. That's not easy because you want very high quality of service, right? But it becomes easier with 5G or 6G networks, right? Then we talk about Wi-Fi 6. So the latest Wi-Fi 6, which is again on the order of gigabit per second or even much more, right? Tons of Gbps. So we'll soon see Wi-Fi 6 and Wi-Fi and 5G in the car, and now you can imagine the plethora of services and applications that can be enabled in the car, right? So it's amazing. All this is open to research for those who want to do, right? Not difficult because you have simulation tools, you have MATLAB, you have LS2, LS3, many are open source tools that you can do research with. Okay. And I'm going to again emphasize that 5G is becoming a very important technology because 5G not only gives you enhanced mobile broadband, but it also gives you mission critical services and IoT. So all these are really under the 5G broad use case. All right, we'll skip that. Okay, one of the key challenges in this sector, which is smart car sector, is cybersecurity. And I tell you, for those who love machine learning AI, today a lot of us are using machine learning in cybersecurity, in intrusion detection, intrusion prevention, denial of service attacks. How do you infer that attack could be that? How do you know the attack could be that? That's not easy, right? Somebody the other day said, I think we were having a meeting with a student. They said, how do I know that the device is faulty? Let me give an example. Let's suppose I keep 10 sensors in this room, right? 10 IoT devices in the room. And I ask the students, and I give an assignment. Prove that, convince me that, no. So I tell the student assignment is, find out which device is faulty. That's not easy. That's not easy. So I repeat, I'll give you n IoT devices in the room. It could be like this. And I'll tell you, use your software, your laptop, Wi-Fi, any, but tell me which device is faulty. It's not going to be easy. How will you find out it's faulty? How will you infer it's faulty? So you will use a lot of machine learning, right? And you will probably figure, ये तो outlier, ये traffic ठीक नहीं है, you know, consistency ठीक नहीं है. So maybe this is a faulty device. Even that question doesn't have a very clear answer because there are all kinds of algorithms that you can use to infer something is faulty or not. So in the car, there are so many possible attacks, right? We call them attack vectors. Attack vector. Vector, you know what a vector is? One-dimensional vector. So x1, x2, x3, x5, xn. So attack vector इतने ज़्यादा है कि आप कुछ भी करिए, there'll be some other attack. Just when I tell, oh, I solved this problem, there's no, you know, software is perfect, hardware is perfect. Some students will come and say, no, I kind of found a bug. I've launched another attack because there's one more channel which was there, Bluetooth channel or Wi-Fi channel or maybe near field communication or RFID channel, and I found an attack over there. So you can never sleep in peace. It's a world where, you know, you really don't have any closure. There's nothing called perfection today. There's nothing called perfection. If you tell me I have a perfect system, I'll probably laugh or I'll cry. It's not perfect. It's good till today, but tomorrow a smart student will say, I've hacked it, it's not perfect. And then you'll say, okay, let me solve the problem. So perfection is gone, right? So you can see that how many attack vectors are possible. Whether you can hack the airbag, you can hack the airbags. Can you imagine? You can hack the airbag. I'll give you an example where the two smart engineers in the US, they hacked a car, the Jeep Cherokee, and they turned the car using just a Wi-Fi link from their laptop to the car. This was 10 years ago. And these two students called Chris Walasek, can do a Google search. Charlie Miller, I've met both of them in Detroit. Charlie Miller and Chris Walasek. इन्होंने कुछ नहीं किया, बस कार को टॉपल कर दिया वाईफाई से अपने लैपटॉप से. They became overnight celebrities. Today, when you people meet them, they say, "Oh, Charlie Miller, oh, Chris Walasek, the same famous guy." They were just kids, you know. They were undergrad students, but they were great hackers. Right? So look at their claim to fame. Right? Today, when I call them to the conference, they say, "I will certainly come, Raji. My charges are $50,000." So my answer is, "Take a walk. We're not interested. We're not interested in giving you $50,000. We'll call somebody else from maybe some other place. So the people, that's how they become famous, by doing something which is so useful and changing the whole game. Okay. Now, what we are seeing now is the world is becoming more and more complex. Okay, not so. So, what is the moral of the story here? Security is a great area to work in, and also apply machine learning and AI. But security is become, just when you thought that security is from a bank, I know people are saying I'm not only happy with security. You also need privacy. You also need safety. Remember, you won't fly a plane without safety guarantee, right? So now they are saying I need safety, but safety can't be defined. So it's turning out that safety has to be mathematically defined. I have to have a theory of reliability, theory of, I need to have reliable system, I need to have resilient system, safe systems, and ensure privacy and security. And I'm like, God, forget it. I'm not interested. I've got to Banaras to take a sannyas. It's too hard a problem. In my life, I'll never solve these problems. It's too complicated. But that's the life of a researcher, right? You keep doing it till you achieve some success. And then there's a new metric called trustworthiness. So the days of saying कि मैं सिर्फ security में काम कर रहा हूँ are over now. Because you also have to focus on privacy, right? For reasons you know very well, thanks to your cell phone, right? Privacy is critical, thanks to cloud. But you also need all these five. So these five metrics together, five tuple we call it, five tuple. They are called trustworthiness metric. So एक नया metric शुरू हो गया है industry में, trustworthy. Is my system trustworthy? And so I'm saying, but to prove trustworthiness is going to take a long time. Hundreds of engineers, huge money, and maybe a decade worth of research, right? So that's where we are now. But please remember, there's a new kid from the block called trustworthiness, which is much more than security. And now we're talking about, so now let's come to machine learning AI. So now we're talking about cognitive security. Can I have security fully enabled with machine learning and AI that will tell you systems, are they working correctly or not? Is this attack? Can I identify denial of service attacks? Can I solve it? Can I mitigate it and so on, right? So even there are many startups now working in cybersecurity, applying ML and AI, and they call it cognitive security. It's becoming a very hot area now, cognitive security. And I'll give you some examples later on, but you can ask me questions at the end of my talk. Okay. Okay. Quickly look at, before I come to AI ML in depth, some of the recent problems. What are the game-changing application services in the automotive sector? I've already spoken about OnStar, right? So clearly OnStar changed the game 15 years ago. The moment the automotive sector partnered with the service providers of the telecom sector, they changed the game. Or GM was not a profit-making company, was making losses. But the moment they announced a new service called OnStar, boom, $1 billion profits. Because it's service, right? After the sari companies, where are they making their profits from? Right? All the companies. I can name Flipkart, right? Name your Ola, Uber. It's a service. It's not a product. Product I have back right? It's a service. And the service is scaling because all of us are using it. That's where the money is. The money is in scale. So you may be the sharpest mind in the country, but if you cannot get million people to buy your app or to subscribe for your app, you'll never become wealthy, right? You may have the best app in the world, saying कि मेरा app पर लोग पूछेंगे fund करने वाले पूछेंगे आपके कितने users हैं, आप बोलोगे 100. Oh, lovely, take a walk. Don't ever show your face again. You need 1 million users to get some money from the venture capitalists, right? So the question is that you need to ask her, what are the game-changing services you have? And one of them was OnStar. Okay, and by the way, coming to Flipkart. So who's the founder of Flipkart? Yeah, so all of you heard of Sachin Bansal, right? Yeah? Sachin Bansal is the founder of Flipkart. I must go to my by summer intern. That time he was I remember Sachin Bansal, such a shy student who wouldn't talk to anyone, just working coding, algorithms and all that. Who knew one day he'll be the founder of Flipkart and sitting on $10 billion? But now when I write to him, he won't respond to him. He's too big a man. That's okay. Won't change it, right? Yeah, all these students, many of them were, I had the privilege of working with these guys. But I'm just telling you this because look what they did. They created something which is new and to change the whole game, and there were millions of subscribers, and they took off from there. The other thing, let's take some other example, right? So I think OnStar should be clear to all of you. Look what's happening now, thanks to big data analytics. Look at this figure carefully. Now you have a company, this is again old, 5-6 years old. There's a company called Progressive Insurance in the US. You have a device, you put that in your dashboard, just like a USB, put it in your dashboard. you know what it will do? It will monitor how you drive. So so if you drive bad, either you're a bad girl or a bad boy, which really means maybe you're drinking a lot. I mean, to me that's not bad. That's good actually. But if you are drunk, or if you are going late nights partying and all that, and you are driving, so obviously you're driving, you'll be pretty zigzag, right? You're a bad driver. So what will snapshot do? It will increase your insurance costs. But if you're a very good boy or a very good girl, straight driving, no problem, nothing. I just have my Cokes and Fantas and drive my car. I will not have beer and drive. Then you're a good boy or a good girl, right? Quote unquote. Which means you drive very well, and so insurance comes down. So this is a dynamic insurance, because otherwise you'll pay $150 a month for insurance, which is very expensive even in America, very expensive, right? So imagine, thanks to this device and thanks to big data analytics and machine learning, that it's monitoring how you are driving. Now you'll say, how do they do that? It's not very difficult. They'll say how you turn the wheel, how do you press the brakes, how do you press the accelerator. They're measuring all that. There's sensors everywhere. They're measuring the data coming out of that. It's a big data analytics, right? They're analyzing the data, and in real time they're figuring out, are you a good driver or you're a bad driver? And they're jacking up your insurance or bringing it down. People love this service. Just look at progressive insurance and you get those. Thanks to machine learning, right? Good, and this is a service. It's a service. So again, somebody who thought of this idea became a millionaire overnight. It's not a rocket science, right? No. Most of the ideas today are not rocket science. Trust me. In fact, this debate I had the other day, I had an argument with my friend. I say, India mein zyada startup, why do we love food, man? I mean, food. Isko dekho, food startup, drink startup. Forget it. Enough of food. Kitna khaoge? I'll give you food 24 hours, will die. How much will you eat, right? Can we think of startups which are non-food startups? Think of ideas which are not food and drink, for God's sake, right? I mean, let's not waste our time on just food and drink. There's nothing wrong with that. Can we think of ideas? अब एक नई startup मैंने देखी paper में, I was telling my wife, and now you can rent a Mali. Oh God, rentamali.com. I'm saying, God bless. Will people give brains to our colleagues in this country? What's happening? Why are we not thinking of fundamental ideas which are going to change? Rent a Mali, rent a mic. I mean, I want to have 10 startups, rent flowers, rent mic, rent chairs. Is that an idea? It's the dumbest thing you can think of. But they're making money. So one has to be careful criticizing them. But I mean, coming from a technical world, one is a little bit skeptical. Why is 95% startups so such shallow area? Why can't we think of something much smarter? You think about it, I think about it, and let's come up with something which is much more smarter. So in summary, if you look at this sector, which was an example for all of you, it's clear that as you go, what are the trends going forward? By 2030, the cars will have they'll be controlled with AI, machine learning, and digitalization. This is the prediction in the next 10 years. So you'll have a lot of code, supervised learning, unsupervised learning in the car, sitting at the platform. It's an edge gateway there, edge server there in the car. And it will intelligently help you navigate. It will tell you, find you the path to destination and conserve your energy and so on, right? So much for the automotive sector. Okay. And so what's the moral of the story? The moral of the story is no matter what you do, I only picked up automotive sector, the car sector, right? You can have any sector. You can have smart building, you can have airplane, aerospace sector, you can have intelligent transportation, you can have healthcare sector, right? In hospitals where they're using machine learning and AI. What's the summary? Summary is AI and ML is all over, it's everywhere. You cannot do without it. So today, if you have skills with AI and ML, you get a great job. And sometimes I kind of wonder, and I can share something very confidential with you. So one of my students, don't quote me, one of my students, that guy is on the top of the right in India, one of the top of the India. We got a job. I said, I said, without my salary tag, the kiddo, BTech, 1.25 crores. I said, I never seen that money in my life. I mean, who earns that much other than maybe Sachin Bansal and others? BTech? Where are we heading to? So then there are arguments. No, I wish the company gave this money to 10 smart students. So 10 ideas, but that's a philosophical debate. Why is that happening? What is the reason? Because this area is becoming so hot. If you specialize in these areas, sky's the limit. But you have to be very good at them. You'll be competing with the best minds in the country and the world, right? This is what is happening now, right? Things are changing. There's talent wars going on. There's, of course, money all over because technology is driving it. And the talent wars in India are very acute. Very hard to get a talent. Ask me, I run my own startup as an advisory board of some startups. People keep saying, Rajiv, give your students. How many students can I give? Oh, one job, you won't work in 10 jobs. So how can I recommend students? Because, they'll ask for a bombshell. So very hard to satisfy. So, okay, so let's move on to some interesting, learning from us. Let's quickly move on to, so what are the computing and communication systems? How are they evolving? How is computer science evolving? Quickly. So one quick answer is, well, today you have 5G networks, and then we don't know what's going to be the future. I don't know what's going to happen 5 years from now. I can tell you in a few years from now, there'll be a lot of very high bandwidth. You can see 10 movies at a time on your cell phone. Not that you will appreciate it, because you see one at a time. But you can do a video call, see a movie, watch TV, but then you're crazy. You still do one at a time. So I don't know why you need 100 Mbps on your cell phone. But they say aane wala hai. All of us are working towards that. So we work on lower layers of protocol stack, right? So dekho kab aayega, but aayega. So 5G will become 6G and will become 7G and then 10G. And I have a professor called Professor Ramji Prasad. Say kabhi to wo bhi din aayega jab Ramji bhi hoga. NG has become Ramji because he's a 5G pioneer, Ramji Prasad. So anyway, so the networks are evolving very rapidly. Number one, number two, there's a lot of action happening at the edge. Important figure because these are all IoT devices. So all these sensors and actuators are IoT devices, Internet of Things, right? And then you have a cloud over here. The cloud is too far. Amazon cloud could be sitting in Singapore or in Dubai or in Seattle or probably in Frankfurt. It's too far because by the time your data goes and comes back, the latency is probably of the order of many seconds, which is not acceptable in real-time applications. So you now have edge servers, edge devices, which are sitting somewhere in between. So a lot of your data in machine learning and AI is stored at the edge. Cloud mein to hai, cloud mein the final data jayega, no? When you need it now, as I'm talking to you, it will be at the edge because edge is much closer to you. See, you can see it much closer to you, right? For example, edge could be maybe outside college or maybe somewhere in Punjab. It's not all the way to Bombay or to Bangalore, right? So there's a lot of action happening in edge. And why is this important? Also because, see, the challenge with working with edge is that the edge devices is because these devices are resource constrained. They don't have as much memory or compute power as cloud. They're resource constrained. But you still have to run your machine learning algorithms on the edge. That's a research job. How do I do that? It's like asking a question, can I run, you all work in this, you work, right? Can I run my random forest or whatever? Can I run my supervised learning or unsupervised learning on the cell phone? The answer now is no, I cannot, because they consume a lot of energy. They consume a lot of time. Processing power is very high. I cannot run my machine learning on this phone. But good news, in a short time from now, you can answer it yes. Because I'm working on tiny ML. The whole new area called tiny ML, tiny machine learning, where the idea is, can I adapt my algorithm on these constrained devices, which have very limited memory, limited power? Answer is yes. So that's a hot area of research, tiny ML. So edge is becoming very important. Machine learning, of course, as I said, it's all over. Today we are at an era of deep learning. Everywhere there's deep learning. What is deep learning? Deep learning is, what is deep learning? Deep learning is a machine learning technique, ideally for videos and audio, right? So if you have a video, if you let's say have a video clip coming or audio clip or images, and you want to classify them, right? Let's say I have an animal and I want to classify, or I have a zoo and I want to classify animals. This is tiger, just automation, right? This is tiger, this is dog, this is elephant. Then that's one example of, and I'll see the images, right? So I'll do deep learning. Or let's say I'm seeing a video clip and I'm trying to infer who's the terrorist, right? Imagine I'm seeing a video clip of a smart city, like indoor. There are cameras all over, and my boss says, "Come on, Rajat, tell me who's a potential troublemonger." So what do? I look at the facial expressions, look at degree of nervousness, right? Look at the actions, and who will do that? I won't do it. Machine learning, deep learning. So deep learning is nothing but a set of algorithms like convolutional neural networks. There are many layers of CNN, right? There's layers of this network, which will then take an input and give the output, which is classifying, which is identifying, classifying, segregating, segmenting. All that is done in an automated fashion. So that's done by networks like convolution-driven networks. We call them CNNs, right? So if you read CNNs, and we've done a lot of work in CNN in the last few years, what is the open research challenge over here? That can you apply CNNs on the edge? Now you'll ask me a question, why the edge? Because cloud तो आपका बहुत दूर है. Cloud में तो आप कर ही रहे हो machine में, वो तो हो ही रहा है. Edge में अगर आप करोगे, you'll get answers much quicker because the application is real time, right? So you will actually run the CNNs on the edge, but the problem with edge has limited computation power, limited resources, limited memory, and they'll consume a lot of energy. So how do you do it? That's the open research problem. So many of our papers, and I'll be happy to send you some of papers in the last 1 year, are talking about the performance of CNNs on edge computing. Right? And found some very interesting results. For example, how do you split the CNN between the edge and the cloud? You keep some layers X1 over here and X2 over here. How do you split? Where do you split? And how will it give? What's the accuracy and what's the convergence time of that? So a lot of interesting work is happening in the last 1 year with students right there. Okay. So running the DNNs, deep neural networks on edge is an important area of research. So what we see is when you write a paper or when you investigate these areas, please remember there are these 5 key metrics. What's the design space? You always have to see that your algorithm is accurate. The higher the accuracy, the better it is, right? You'll make your money or you'll have a good paper. So 0.95, for example, is a high accuracy, 0.99. But if your algorithm is only 70% accurate, not much, right? It's like saying that why will anyone take your if you propose a solution, why will they buy it if you say its accuracy is only 60-70%? They'll not be convinced. One. So you have to have high accuracy. You have to have high security. You have to be aware of the memory consumption, latency, the delay, right? And of course, you have to be worried about the energy. How much energy does my algorithm consume, expend? There's one more metric called the convergence time. How much time it takes for the algorithm to converge to that particular accuracy. So now you realize that when you work in this area, which is machine learning or AI, machine learning is a subset of AI, you will have to take care of all these metrics if you really want a good paper. Otherwise, it's a gap there, right? There'll be a gap. So you have to look at energy becoming a very important part because edge may happen. Okay, another important area is federated learning. So recently, in the last 6 months, the last actually 1 year, my students are looking extensively at federated learning. A very interesting concept. And why am I sharing this with you? Because there's so many new ideas in machine learning, right? I don't want to share with you supervised learning, that's old now. Everybody knows what supervised learning is. Binary, the random walk. You have all kinds of algorithms. You have random forest. You have k nearest neighbors and so on and so forth. But you really want to figure out what are the new trends in this sector. Okay, right. So what is federated learning? The idea is, can you distribute machine learning across n nodes? Very interesting problem. Listen to this carefully. I have n nodes and I have a central server, but it's a distributed system, right? So each node now, what's the key mantra of federated learning? Privacy. I want to maintain privacy. So these protocols are called privacy preserving protocols, privacy preserving algorithms. Because today everybody wants their privacy, right? Why should anyone know what you're doing on the laptop, on your cell phone or your laptop? And you may be working on a very important government media project, right? Privacy is critical. Or your own financial data, right? Why do you want anyone to? Not even your family, right? So privacy preserving algorithms are very critical. One example is federated learning. So what it does is that the data is stored on each of the nodes, each of these we call the worker nodes. The data is never shared, but the machine learning model is shared on each node. So this server will send the model to each node. The node will train that using its own data, send the weights back to the server. The server will take an average, also some statistical average. It could be any measure of average, not just simple 1 by sigma xi, but it could be much more complex average measure like exponential smoothing, right? We could take all kinds of averages over here and then keep iterating till you don't achieve accuracy. So federated learning is becoming a very important area, and you can work at Python, PyScript, and all that. There's a lot of open source ways to open source packages to help you work on federated learning. Now there are many open areas over here. How do you distribute data across these servers? They're called worker nodes, right? What are the statistical challenges? What happens when you have communication cross between the server and these nodes, worker nodes? How do you choose the worker? That's not how you choose the worker node, right? Or these devices, the client device. What happens when some workers when they are faulty? So when they're out of the network, what do you do then? Right? What happens when the data is unlabeled? What happens when participants are dropped? What happens when So I think there are many open challenges in federated learning, and an area of great interest. And I think the most important challenge is I don't even know what is the application that will use federated learning. So many times when we write papers, we always ask the question: application plan. Let's define the application. And that is very important. Without the application, it just becomes a theoretical exercise, which gives you a paper but may not be any industry will not buy that idea. So there's no application. So fed learning is a hot area in the umbrella of machine learning. Let me conclude and then give you some interesting last few slides, and I'm not taking a lot of time. So what are the hot topics in AI and machine learning? What are some of the really hot topics, right? So today we see that almost every group in the US, in Europe, and many in India also, in Microsoft Research in Bangalore, in Google in Bangalore, Amazon Research in Bangalore, and all these people who are heading it are good friends, the country heads of these companies. They're both doing some great work. They are looking at bias in machine learning. What is bias? How do you make sure your algorithm is not biased? For example, how do I make sure my algorithm is not biased towards women? Look, you never know. Or biased towards men, right? Or biased towards young people. So old people will never get a job, right? If you're beyond X years, you never get a job. You never know, right? Bias could be any bias, right? How do I remove the bias? It's a hot area of research in machine learning, right? Bias remove करना आसान नहीं है machine learning. So वो बहुत जरूरी area. Then you have fairness. How do you ensure that the algorithm is fair? It's fair. It's giving you fairness, which means all of us get similar results. ऐसा नहीं है कि आप अगर senior तो आपका it will favor you more, junior it will favor you less. Fairness in every sense, right? And finally, the area of explainability. What is explainability? Can you explain to a layman कि ये machine learning में क्यों use कर रहा हूँ, कौन सा algorithm use कर रहा हूँ, और उसका results क्या है? Because the layman has no clue. Layman has no clue, right? I mean, a common man who's not in science or engineering will have no clue. They'll say, हाँ जी machine learning हो रही है, Google हमारे को result दे रहा है, like all your Flipkarts and Amazon, right? You're getting target products. That's because of machine learning. Yeah. But the layman doesn't know कैसे हो रहा है, right? You type in an email and boom, you get an ad. That's machine learning. Google is playing a game there. Google is running their federated learning at the back end, which is a fact. Google is running their federated learning at the back end and trying to bombard you with the latest based upon what you type, how you type, and everything else, right? What your words are, what your emails are. It's a dangerous world, right? So explainability means can you explain why the algorithm is being used and what the results are, and why are the results the way they have to be, right? To common public. And of course, we have fed learning. You have a new concept called multi-agent reinforcement learning in AR. I'm actually now doing some interesting work in AR now. Then you have deep neural network optimization. The list goes on and on. It's a very interesting area to work. Okay. So we are now seeing an era of autonomous and cognitive systems. Clearly, what's the future? Dangerous future. If you look at the peak, if you ask me, what will happen few years down the line? Not 10 years, I have no answer, 5 years, no. Few years down the line, this is what's going to happen. You will see a convergence of cognitive systems, and these systems are nothing but, cog systems are deep learning systems where they mimic, so systems with deep learning and neurocomputing where they mimic neurons, they mimic synapses, for those who do biology, they mimic synapses, the communication with neurons in the human system or animal system. Can you mimic that? So intelligent communication or intelligent interaction. Neurocomputing and AI, ML, and DL are really cognitive systems, and then you are in an era of quantum computing. So when I talk to friends in quantum computing, they say, Rajiv, all the algorithms that we have in cybersecurity, even the most powerful algorithms, which give you security, like the elliptic curve cryptography, is a very powerful algorithm. It's not broken down, right? So it's a public key cryptography, which is proven to be unbreakable till date. But the moment you have quantum computing, you are done. There's no security. You have to design another algorithm, right? Quantum will kill everything, right? I mean, there's nothing that will be secure the moment quantum computers become a reality. So the future will belong to a conglomeration of neural computing, cognitive computing, and quantum computing. Where are we heading to? I have no clue. And so my last slide. So to conclude, there are a plethora of research challenges in the whole area of ML, AI, deep learning, and as I said, right, there are many open problems. Some hot problems are in cybersecurity. I want to detect attacks. I want to infer what kind of attacks they are. Can I prevent attacks? Can I mitigate? Mitigate means can I solve? Can I mitigate the attacks, right? Using machine learning and other techniques. Systems are getting more and more automated. So automation is becoming very important. In TCS research headed by one of my very senior colleagues, Dr. Harry Quinn, has designed a new system called Ignio. So please do a Google search called Ignio, I-G-N-E-O, I-G-N-I-O. You heard of IBM's Watson, right? So Ignio is India's Watson, completely done by TCS research by Dr. Harry Quinn. Hundreds of people involved in that. It's the first cognitive autonomous system coming out from an Indian industry called Ignio, I-G-N-I-O. Just look at Ignio. Okay. So that's an example of complete automation. You will have autonomous vehicles. I've already given you enough lecture on autonomous vehicles. You will see the convergence of connected, collaborative, and cognitive systems and going forward. Clearly, the future will belong to new services and applications, right? So if you can define new services, new applications, that's where you will succeed. And if that service scales with a large number of people, subscribe to that. Okay. It's a great time to have startups, but it's not easy to have startups, right? Much that we think it is. Yeah, of course, you want to rent a Mali or rent a fan or rent a Shadi ka Pandit, that's fine. Please, I don't call that a startup. I call it a dumb up. Let's not talk about those areas, but if you want a technical startup which will change the game, it is a lot of work, lot of time, lot of money invested. And of course, I'm not saying you can't do it, but it requires tremendous amount of insight, right? But it's a dangerous world out there because the more intelligence you have, the more distributed systems you have, the more automation you have, it opens a Pandora's box of disaster. Systems can crash. Imagine an aircraft just imagine a MiG or a Mirage or an F-16 flying to an enemy country, which is completely automated with AI ML. With all the top secret, it crashes an enemy land, or right? Or it's hijacked by someone because of wireless channels and hijacked. It can have all kinds of man-in-the-middle attacks and all, right? So the dangerous world out there. I mean, your cell phone today. Good luck. Today I get an email from Google saying, Rajiv, this is all the places you have visited in the last 1 month. That's not a good sign. Right? I mean, I may be a defense guy going to DRDO. Why should Google know I went to DRDO? That's not a good sign at all. So, is there anything private today? There's nothing private. The only way you can maintain privacy is switch off your phone, switch off the GPS. Yes, then you're fine. But switch off the Bluetooth, Wi-Fi, and then you probably are safe and secure and you have privacy. But there's nothing called privacy. You can see the scandals happening on the online. And that's the world today now. You've got to be careful because there's really no privacy thanks to the complete digitalization and mobility around it, right? So it's that worries me a lot. And finally, I am of the view, in the last 20 years of my research, after I finished my PhD, in all these companies, whether it was IBM or General Motors or TCS, I realized that it is critical to collaborate. And that's my last statement at the top of today in my talk. If you don't collaborate, you will never be able to do that. Take my word, you remember me next 20 years. Because it's a tough word. You may be the JEE #1. I tell this to my students. You may be the IIT JEE #1. Who cares? Who cares? Nobody cares. If you don't collaborate, you cannot come out with a successful service or a product. You've got to partner and partner with diverse people. With, men, women. Why only India? Look at Europe. Look at Singapore. Look at Australia. Look at the US. No. Now you may say, "Nahi, hamari nails to answer karega." Try to karo. When students send me an email and they're sharp students, well, if they have good idea, I will respond. Why do I keep quiet? I'm an idiot. I'm not an idiot to ignore a talent, right? So try to connect with people who are good, who done well, who are sharp, who are smart, all over the globe, not just India, right? Because we don't collaborate. You could be a professor. Today I've seen this. If you don't collaborate with people, I collaborate with my friends in Cambridge University, with people in the US, in India, of course, obviously, right? My students at Rajiv, sir, why are we? I said, look, understand. I have ideas, but I can get, maybe somebody thinks differently and will have some other ideas. And that together the people will be much stronger, right? So collaboration is the mantra of the day. How you collaborate, I'll leave it to you. Don't collaborate. And it's the same with academia or industry. There's no difference at all. And my last comment is that all the awards you will get in life, and all these awards that you probably heard when they increase me, sometimes I think it's not because of me. It's because I collaborated with well-known people, and maybe they are very kind enough to nominate me for the awards. Why did awards come? And not just me, I'm talking about anybody else. Why did awards come? Because I collaborated with them. Would they have ever nominated somebody or given a reference letter without knowing me physically, face to face? Answer is no. So your success is not your success. It's a collective success of all those who are around you, within and out of the ecosystem. Thank you so much, Anna. I'll be happy to take any questions from any one of you. And I hope I gave you an overview of where we are today. I just didn't have the time to go deeper. I will have to send you my paper. So we gone deeper into each of these areas as I'll be happy to share my results. So each of the area you saw here, whether it was IoT or whether it was edge or whether it was deep learning, we've gone deeper and seen some very interesting research problems. But there was no time to go deeper than this today. Open to questions. Yeah, please. Introduce yourself. From the college. Right.
So, what are the problems when AI has an edge over machine learning?
AI has an edge over machine learning. No. See, AI is a whole. So AI is you got statistics, right? So AI is a sample space. It's an entire omega, big omega sample space, and machine learning is a subset. It's omega 1. It's a subset of that sample space omega. Right. So AI can include your heuristics. AI can include your expert system. Machine learning is very clear, supervised or unsupervised or deep learning. So AI is everything here, right? But when you go deeper, you say, oh, this is machine learning, and now within machine learning, I have deep learning. So it's AI, which includes ML, which is a proper subset, which includes deep learning, which is again a proper subset of machine learning. So AI is a grander sample space called omega. That's the way I look at it. Question? More questions from anyone? Yeah.
So, can you think about big data?
Big data is nothing but a large number of data, a huge amount of data of the order of petabytes, which is distributed, and you have to make meaning out of it. So let's take an example. Let's say I want to, I'll give you an example for the college. Yes. So let's say I know, let's say a principal gives me data of every student in this college. Every student, right? Data means not just your performance, but your aptitude, your hobbies, your kind of your creativity and all that. And I'm to ask you, Rajiv, now your company, your startup will tell us which student is likely to excel in the design field, which student is likely to excel in the science field, in the engineering field. If I can answer that, then I need that huge data. So big data is nothing but big data analytics. You need to use analytical techniques to mine the big data, but it assumes that I have the data with me. Without data, I can't get any answers. But getting data is the hardest in the industry. Who will give the data? Privacy issue, right? Getting data is the hardest. Now you can get data from open source, like Kaggle mein aap jaiye, or go to NIST, or go to all these well-known NNIST or Cypher 10, as many of you may know. You can get data from open sources, but you may not get data that you want in your area. Then you have to partner with a hospital, partner with a college, partner with governments, partner with the other people to get that. Yes, that's right. Any questions, please?
And IIT at this college, Department of Computer Science. So I want to know that how can I introduce AI, machine learning, and many technologies for our humanities students?
Humanities students.
Yeah.
I see.
Because there are many programs here which computer application is involved, like economics, geography,
Right.
and mathematics. How can I motivate these students because they have not any core field like honors?
Yeah.
But these students are BSc honors. So they have chance to go for MCA, MTech, and maybe such like a program.
Answer is there. Yeah, good question.
I think there are so many questions. I think the questions will be coming since we have any limited time for these sessions. So I think we should.
Yeah, I'm going to wind up after this. Sure. You can ask the question on debate.
How can I motivate these students who are belonging to humanities subjects?
I got the question. So the answer lies on this slide. I mean, a lot of areas like the bias and fairness and explainability and many other areas are really the areas where our friends in humanities are working on, right? So you don't need to be a deep expert in machine learning to understand the bias. So you can write a term paper, you can write a survey paper or term paper in many of these. So AI as an area here that you can always ask your humanities or commerce students to look into non-technical aspects and get some insights, right? That's not a very good thing. We can talk often. So exactly an area where a lot can be done, even though you're not technical. Although technology, of course, is important, but the non-technical aspects also very important. So I'll be happy to take any other questions outside, but I think with that I'm going to stop.
It is right. It is rightly said by Dr. Shore that if you want to succeed in life with technology, partner with industries, increase your horizon and collaborate more and more. I hope all of you have gathered enriching knowledge from such an informative session. Thank you, sir.
Thank you.
It is now time to take a break and hence would request all of you to proceed towards the refreshment menu, activity room nearby the canteen to enjoy the tea break and gather here again at 12 p.m. Thank you.
Yes. Yes. Yes, yes, yeah. They will ask questions. Big data. So research very let's go. I think idea
Everyone need to carry their identity cards to the refreshment room as well as to this venue. Thank you.
After doing, yeah, it's once you know the domain, like, what's the question you ask? Are you extrapolating? Are you answering to your trend? So let's take an example. Let's say I have this card and my students question what is the trending clothes that will sell, right? Which color will sell better?
which color, what's the age group which will buy that color. So they are all kind of question of predictive analytics. So there are many answers. You can predict predict shape and you can buy. Right. How are you? Yes. So you have all kinds of there's a whole new world of prediction maintenance. Can you predict that the machine is failing well before it fails? Which
Good afternoon to one and all present over here. With immense pleasure, I welcome you back for today's special day. I hope all of you have had and enjoyed the refreshments. If everyone is moving forward together, then success also takes care of itself similarly. So by this line, let's accelerate our journey by introducing the first resource person of the day, Professor Girish Nadja. Professor Jha teaches computational linguistics at the School of Sanskrit and Indic Studies in Jawaharlal Nehru University, JNU. He is also a concurrent faculty in JNU School of Engineering, Center of Linguistics and Special Center of E-Learning. I would now request our teacher in charge, Dr. Jaya Geda, to come forward and present a token of gratitude to Professor Girish Nadja. Ma'am, please. Thank you, ma'am and sir. I would now take the pleasure to welcome Professor Girish Nadja, who teaches computational linguistics at the School of Sanskrit and Indic Studies in Jawaharlal Nehru University, JNU. He is also a concurrent faculty in JNU School of Engineering, Center of Linguistics and Special Center of E-Learning. He has previously served as the director of JNU's International Collaboration, chairperson of the Special Center of Sanskrit Studies, and founding dean of the School of Sanskrit and Indic Studies in JNU. Professor Jha's interests include Indian language corpora and standards, Sanskrit and Hindi linguistics, science and technology in ancient texts, lexicography, machine translation, e-learning, web-based technologies, RDBMS, software design, and localization. Professor Jha has several publications to his credit, supervised 35 doctoral research students, and has completed many key projects and consultancies, leading to development of resources in Indian languages. He has been awarded for his work on Sanskrit linguistics and revival of ancient script Sharada. Now, I would request Professor Jha to address the participants on the topic, Resource Creation for AI, Challenges for Multilingual Societies. Please, sir.
That's like 2 minutes. Anyway, thank you so much, Sir Gera, for inviting me to this eminent college in Delhi University. I think I've been here before. I'm not sure because the whole building looks so new. No? So maybe I'm here for the first time. I've been to many colleges of Delhi University, and perhaps for the first time to this college. Thank you so much, and my gratitude to the administration, honorable principal, head of the department, and other faculty members and students of this campus. So I'll be taking you through the process of resource creation for artificial intelligence. AI cannot happen. AI cannot happen unless machines are able to understand natural language, right? That's how the father of AI, John McCarthy, said it in, when he coined the term artificial intelligence in Dartmouth conference. And natural languages are so complex. And in India, they become much more complex because of our diversity, right? How many languages we have in India? Anybody? More than one? 2,000. How many? 40,000? More than 1,000. Anybody? So as per 2011 census, we have, of course, 22 official languages of India. And सबको अंग्रेजी आती है ना, ठीक, कोई दिक्कत नहीं अंग्रेजी में ना, बता दीजिए. And out of these 22 languages, we have Hindi as the official language, national official language, and English is not a national language of the country, right? But it is a very important language. यहाँ के 10% लोग अंग्रेजी बोलते हैं, तो बड़ी भाषा अंग्रेजी देश की. And then there are, of course, many more languages, 37 of them waiting to be included in our constitution. So that will make 57 or 59 languages in our constitution. हो जाएंगी. अभी तो 22 हैं. And then the government has this onerous task of creating technology for all of them. Hindi, as per unconfirmed statistics, we have about 81% people of the country who can speak Hindi and use Hindi. That makes Hindi the big language of the country, right? And that puts many other languages, uncomfortable because of Hindi's rise. Means that there'll be some casualties on the way, right? And then there are other very important languages besides Hindi. We have Bangla, we have Telugu, Tamil, spoken by large majorities, Punjabi, of course, and Urdu, Hindi, Urdu are the same languages, in two different scripts. And then there are 270 mother tongues discovered by 2011 census. And the new education policy, the national education policy, has promised that they will teach primary education in mother tongues. How is that possible? Can you teach everybody in 270 mother tongues in India? They're still struggling to provide schools, and the roofs to the schools, basic facilities. Can we provide content in 270 mother tongues, textbooks in 270 mother tongues, and teachers? जब हम स्कूल में जाते हैं, so we leave our mother tongue behind. We start using the major language of the region. When I went to school, I left Maithili. I started speaking Hindi in the school. So that happened. It's very normal in India. So can you have teachers who can speak all mother tongues? That's impossible. So you have technology. करना ही पड़ेगा. You have to have technology. So and that's how we can actually address all our nations. Besides 270 mother tongues, which are spoken by at least 10,000 people in the country, there are thousands of languages in the country, and we can't let any language die. So therefore, we have to have resource creation in each of the languages and make technology for all of them. Oh, I can use that. Okay, good. It's good. Next. Now we are fortunately and unfortunately we are in the data-driven AI, and there's so much of data in India, so much of it actually. इसमें करना क्या है कि we have to have data और data को लेकर train करना है systems को. But the problem is both data and technology are changing very, very fast, faster than ever actually. 2000 के बाद there has been a tremendous speed with which technology is changing, data is changing. The kind of data that is coming onto the web and social media is amazing. I'll give you some examples, of how people are using data on internet. And if you look at the technology, how technology has evolved from the 40s, I've taken this slide from my friend David Gibbon. From encryption, decryption to machine translation to theoretical informatics and psycholinguistic interpretations of parser generators, logic inferencing to 2000. Look at 2000. Web has come and a lot of resources available. So technology has changed from the classical AI of training systems with grammar and lexicon. We are now training with data. So data is very critical today. And data which is coming on internet is all chaotic. And computers are changing. There's phenomenal growth in vertical growth in the storage capacity, in processing power of machines. Technology becoming cheaper. So future is uncertain because technology is changing very fast. Data is changing very fast. We don't know where we are going to head. And India is a diverse country where we need cheap technology, cheap AI, accessible to all. So we have to innovate. Even if AI changes outside, we have to make changes again in India to make sure AI is applicable to our country. Look at AI in the 90s. I did a course in Introduction to Artificial Intelligence at University of Illinois, Urbana-Champaign, where I was doing my master's program. And that was a course in Introduction to Prolog programming and Introduction to Lisp programming. So if you did a course in AI in the 90s, you would be doing a programming course in Lisp and Prolog, the two AI languages. If you do a course today, you would be doing machine learning and deep machine learning, invariably, right? Despite, the future is uncertain despite the computing capacity and storage rising phenomenally. क्योंकि हम नहीं जानते कि कल ऊंट किस करवट बैठेगा, किधर जाएगा, we don't know. AI of previous decades required grammar and lexicon. We needed a good grammar, a formal grammar, and of course a lexicon created as per the grammar formulas. I'll give you an example. Please go to the next thing, please. Oh, sorry. Now, these are some of the models that have been traditionally used in artificial intelligence till the 90s, I would say. Astadhyayi has a big grammar, the first from India, and the lexical functional grammar, all of them actually the derivations of Chomsky's grammar. So lexical functional grammar, function unification grammar, tree adjoining grammar, and head-driven phrase structure grammar. So if you did a course in the history of AI, you will certainly come across these models. Can you click this link? This link will click. Link to click. Link. Right. Look at this grammar. Attribute value grammar in Pater notation was done for English to SQL interface. So if I have to speak to my database, not in SQL, but in English language, how would database understand? See, everybody does not understand SQL language of programs, etc., Java, SQL, C, etc., Python. But what they know is their language. So if I'm communicating with database in my language, how will database understand? So this was a parser done from English commands to database commands. Now, how do you write a grammar? So basically you write a macros and then you iteratively use macros in the body of the grammar. So I define ditransitive, ditrans, right? And then I define vtrans, vint, and if you scroll down, it's a scroll down key. Please down. अभी सैंपल ग्रामर देखिए. सैंपल ग्रामर में हमने क्या किया है? अभी टेक a sentence, less sentence, command. Commands are basically there is no subject in the command, right? You only have do it, come here. So to database हम कहेंगे भैया select something, data निकालो, हम command देंगे उसको English language में, right? So when I give commands to database in English language, though they will be subject less sentences. So how do we map subject less sentence so that machine is able to translate subject less training program, and then get the testing done, and then optimize. This is what basically you have to do, right? So this is how the platforms available. Core NLP is there. Open NLP is NLTK there. Open NMT that I use for machine translation. BERT hai, Moodle has recently come for 17 Indian languages. TensorFlow pe hai, Indic NLP hai, and हमारा अपना JNU का ILC and platform Indian language के लिए. I'll show you that little later. अब जो resource creation है इंडिया में, we are looking at big linguistic data. I call it big linguistic data, which is coming up in India. It's huge, variable, and gets created on the fly. अब देखिए जितने mobile phones देश में हैं, everybody is using mobile phone. Imagine if a person is using a feature phone, to talk to each other. Right? They do a lot in India. I think almost 70% of the people use mobile phones today in India. So a lot of data being generated. If there's an app in the phone which is going to translate data, rather transcribe data into text and put it on the internet, that way every language in India will be getting a lot of internet data. जो भी नहीं हो रहा, अभी भारत में केवल 0.1% भारतीय भाषाओं की उपस्थिति है इंटरनेट पे. इंटरनेट पे हमारी भाषाएं बहुत कम दिखती हैं. And 53% is English language on internet. A lot of English language content comes from India also. Because 10% of Indians use English. So there is a way to create quick data on internet from Indian languages. To deal with complex data sets as a typical big data, we need smart algorithms. हमें smart algorithms चाहिए जो इस process को on the fly automate कर सके. कैसे करेंगे मैं बताता हूँ आपको आगे. Some examples of big linguistic data from India. अब judicial documents देखिए. हमारे सैकड़ों courts हैं. Saikonro district courts, and then we have high courts in every state, and then we have a Supreme Court. All of them have millions and millions of cases pending. Data का बहुत diverse media में data आता है. I'll talk about it a little later, much more detail. उसके बाद देखिए administration papers हैं, हमारा e-governance है, newspaper, print media, literatures, film, television, Facebook, social media, and the manuscripts in bulk, and then other language historical texts. All of them constitute a lot of big linguistic data, and unless we capture them, हम progress नहीं कर पाएंगे. कैसे progress करेंगे बताइए? हमारा स्वशासन हो ही नहीं सकता. हम we can't use e-governance, self-governance without technology, क्योंकि हमारा self-governance इतना diverse है. अब आप birth and death registration करना चाहिए तो नाम में ही बहुत विचित्रता हमारे देश में होती है. जो बच्चे का नाम ही होगा वही बड़ा क्रिएटिव होता है हमारे देश में. भाषाएं बहुत क्रिएटिव है, नाम क्रिएटिव, सारी चीजें क्रिएटिव हमारे देश में. वेरी वेरी डाइवर्स. हाउ कॉम्प्लेक्स इज द सिचुएशन इन इंडिया? लेट्स लुक एट. ये हमारी हिस्ट्री है. इंडियन डाइवर्सिटी इज फेम्ड इंडियन डाइवर्सिटी, मोर डाइवर्स देन एनी अदर कंट्री इन द वर्ल्ड. पूरे यूरोप में 25 भाषाएं हैं. हमारे देश में कितनी भाषाएं आपने देखा होगी? पूरे यूरोप में मात्र 25 भाषाएं. More than 600 languages and documented literature. Sanskrit more than 6,000, at least 6,000 years. Sanskrit. अभी भी हम संस्कृत को पढ़ पा रहे हैं जो उस जमाने की संस्कृत थी. पाली प्राकृत, अपभ्रंशा, modern Indian languages, oral tradition, and Sanskrit has been a huge influence on all languages, not only Indian but European languages also. The number of Sanskrit words in other languages of Europe is amazing. Lithuanian में हम कहते हैं, जैसे संस्कृत में कहते हैं कहा तुम असि, तुम कौन हो, संस्कृत में कहते हैं. लिथुआनियन में कस तू एसी, दैट इज लिथुआनियन. यूरोप की भाषाएं 25 में से 21 संस्कृत से मानी जाती है. सो वी हैव अ ह्यूज प्रेजेंस. इंडिया में देखिए बिसाइड संस्कृत, फारसी बहुत महत्वपूर्ण था मुगल टाइम में. फारसी में भी हमारे बहुत से डॉक्यूमेंट मिलते हैं फारसी में. FIR वगैरह में लैंग्वेज फारसी की लिखी जाती है. तो एक बार तो कोर्ट में भी मामला आया था. हिंदी उर्दू भी है और अंग्रेजी भी है. सारे इंपॉर्टेंट लैंग्वेजेस हैं. If you see the number of speakers in India, 77% इंडो-आर्यन, जो 15 भाषाएं उत्तर भारत की हैं, नॉर्थ की भाषाएं हैं, 4 द्रविड़ भाषाएं हैं. ऑस्ट्रो-एशियाटिक जो है वो संथाली है, और टिबेटो बर्मन, मणिपुरी और बोडो जो पूर्वोत्तर की भाषा है. अंडमानीज तो खत्म हो गई. Look at these. Devanagari is the biggest script. Bangla is the next big script, and then we have Persian-Arabic, which is not an Indian script, but again a big script. Persian-Arabic also, and then we have Roman also. English 53% plus on internet. Hindi 0.1%, and if you combine all Indian languages, not more than 1% of total presence on internet. पर अच्छी बात क्या है कि 10 में से नए जो 9 लोग अब इंटरनेट पे आ रहे हैं ना, वो सारे भारतीय भाषाओं में प्रयोग करना जानते हैं, चाहते हैं वो, दे वांट टू यूज इंडियन लैंग्वेजेस. So turning to official languages, 37 more coming, and 1700 plus languages and varieties, multilingual media, language policy, governance, health, all of that. And English is a very interesting phenomena. हम अंग्रेजी को mix कर देते हैं हिंदी में, अन्य भारतीय भाषाओं में. We call it English. So words like crazy किया रे, confuse किया रे, crazy बांग्ला में crazy कोरा रे हो जाएगा. And so all this हो जाएगा. Amazon Alexa, Google Assistant, all of them they know how to handle English now. आप यदि गूगल असिस्टेंट को इंग्लिश में बात करें, अभी मैं गूगल का कंसल्टेंट हूँ, तो वी आर ट्राइंग टू डू दैट इन वेरी इंटरेस्टिंग थिंग, हाउ टू कैप्चर यू नो दीस वेरिएशंस इन हिंदी. अब फिर नॉन स्टैंडर्ड मल्टी मॉडल कम्युनिकेशन. हमारे देश में इतनी डाइवर्सिटी है, पीपल, बहुत से लोग हाँ कहेंगे, ऐसे करेंगे हाँ के लिए. तो अब मल्टी मॉडल भी डिफरेंट होता है. अभी मान लीजिए समवन इज ट्रांसफरेबल जॉब, साउथ से, तमिलनाडु से दिल्ली आ गया, हो सकता है उसके जेस्चर्स भी डिफरेंट हो. जेस्चर्स भी होते हैं एज पर योर कम्युनिटी, यू नो, तो वो भी फर्क होगा. एंड स्टैंडर्ड स्पीच, नॉन स्टैंडर्ड स्पीच, टेक्स्ट डेटा, सोशल मीडिया यूसेज, हैंड रिटन टेक्स्ट, मैन्युस्क्रिप्ट में बहुत डाइवर्सिटी है. मिक्स स्क्रिप्ट्स, इन्फ्लुएंस स्क्रिप्ट, जैसे उदाहरण है बांग्ला में आप देखेंगे. So when you write A, हम हिंदी में A लिखते हैं ना, तो बांग्ला में प्रश्न मात्रा बाएं से दंडी लिखी जाती है. तो there was a manuscript of Mahabharata written by a Bengali in Devanagari. तो देवनागरी लिखते हुए उसने बांग्ला का प्रश्न मात्रा डाल दिया उसमें A के बदले. These are historical documents. ऐसे मिलते हैं आपको कई बार कि multiple scripts are used intentionally or also unintentionally. फिर शारदा, जैसे शारदा लिपि को रिवाइव करने का डेड स्क्रिप्ट भी है, you have text in there. अब जो कॉम्प्लेक्सिटी है, we need smarter algorithms and there will be robust new requirements कि भाई टेक्स्ट को प्री प्रोसेस करना है, नॉर्मलाइज करना है, मल्टीलिंगुअलिटी को आइडेंटिफाई करना है. जैसे अब I was searching for भोजपुरी data on internet. We find भोजपुरी, we find अवधी mixed with it, we find हिंदी mixed with it. So कैसे अलग अलग करेंगे इसको? एग्जाम्पल, यू नो, अब मान लीजिए कि कन्वेंशनल हमारा SQL है. Suppose we have a database. You know, I have an idea how to actually seamlessly store data in database. So I'm talking to my family on phone, and there is an app in the phone which transcribes data into writing, and then there's a crawler which crawls the data, and the crawler is interfaced with database with a natural language interface, and it puts data in the database structured way. ऐसा यदि हम end-to-end system बनाएंगे, तो जो लोग बातें कर रहे हैं फोन पे, all of the data will go into database, and that could be of course indexed and used by the search engines. So we can bootstrap crawlers with voice commands, SQL ML, which I showed earlier, obtain target data and store them in DB on the fly, and crawl raw data and train machine learning algorithms. ऐसा करना पड़ेगा आपको. Smarter technologies will need smarter and huge quantities of data. कैसे डेटा बनाएंगे? Can we quick now what is data that we need? For example, यदि मैं कहूँ Sanskrit is the oldest Indo-European language. Simple sentence. If you tag it, how do you tag it? Part of speech tag करेंगे तो हमने कहा XML tag sentence है, पर उसमें ढेर सारे XML tags हैं. Noun का है, verb का है, आर्टिकल का है, ओल्डेस्ट इंडो यूरोपियन, और सारे एडजेक्टिव है, लैंग्वेज नाउन है. तो ये पार्ट ऑफ स्पीच टैग हो गया. इसी सेंटेंस को इफ आई गो फर्दर, डू नेम एंटिटी टैगिंग, आई विल से संस्कृत इज द लैंग्वेज नेम. If you go further, we do sense tagging. So is maps to existential, oldest maps to ancient, pristine periods, so many synonyms, and language maps to speech, communication, other possible words in English language. Similarly, if I do a chunk tagging, can you go down? Yeah. Sanskrit is the oldest language. ये वाला एक chunk हो गया. If you go further down, you can do a sentence tagging. वहाँ पे नीचे जाइए पूरा. हमने कहा कि पूरा जो ये sentence ऐसे है, उसमें noun phrase संस्कृत है. उसके बाद is the oldest Indo-European language word phrase है. इसकी हमने पूरी tagging की हुई है. उसके बाद नीचे जाइए discourse में Sanskrit, which is the oldest Indo-European language. नीचे जाइए. संस्कृत जो कि सबसे पुरानी भारोपी भाषा है, जिसमें ऋग्वेद है सबसे पुरानी पुस्तक, वो भारत की राष्ट्रीय भाषा भी है। तो जहां जहां एक्स लगा हुआ है, दे आर बेसिकली लिंकर्स, वी यूज दोस लिंकर्स इन डिस्कोर्स। जब हम बोलते हैं तो हमारे वाणी में वी हैव दिस लिंकर्स, एंड दी सामने वाले को समझ में आ जाती है बात, बिकॉज ही इज एबल टू प्लेस लिंकर्स। कैन मशीन्स आल्सो डू इट? So unless we provide machine training in such data, machines can't do it. In normal human communication, we use these things. So machines have to understand the layers of meaning inside. Otherwise, please close the window. Okay, good. Right. Now, so who was doing this resource creation? ये बनाना है resource creation, so who will be doing it? Of course, the academia is the leading group which is funded by government of India, industry fund करती है, and then they do it. तो अभी देखिए currently IIT चेन्नई जो है उस स्पीच पे फोकस कर रही है, स्पीच टेक्नोलॉजी पे। IIT दिल्ली शांतनु, IIT चेन्नई उमेश और हिमा मूर्ति, they do speech. IIT दिल्ली शांतनु does OCR, IC Bangalore AG Ramakrishnan does online handwriting. यानी हम लोग लैंग्वेज टेक्निकल रिसोर्सेज एंड टूल्स करते हैं। CDAC, ट्रिपल IITM, some major universities, they do machine intelligence and resource creation. IIT बॉम्बे पुष्पक does machine intelligence and wordnet. इंडस्ट्री भी कई लोग इसमें काम कर, गूगल मैं बताऊंगा आगे भी, मशीन माइक्रोसॉफ्ट, स्विफ्ट की, Amazon AI, Samsung, Adobe, Nuance, ECDI, all of them, you know. And government funds through TDIL program, Technology Development for Indian Languages, तो करती है वो। And but then problem क्या हो रहा है कि जब हम एक language neutral बनाते हैं, I create a general, you know, a purpose machine translation, a general purpose language technology application, तो वो किसी विशेष डोमेन में जाके प्रॉब्लम करता है। If I train a machine translation system for, जैसे गूगल का हमने इंग्लिश से हिंदी किया, जैसे जब गूगल का बना था हिंदी टू इंग्लिश 10 years back, they sent me email, so why don't you have a look at it? We just, you know, uploaded, we just launched our Hindi to English machine translation. तो मैंने उसको एक सेंटेंस दिया, राम आम खाता है, गूगल को, and Google translated राम is a general account. गूगल गलत नहीं था, आम खाता मतलब अकाउंट भी होता है, जनरल अकाउंट भी होता है। तो they were tuned to a specific domain. अब उसमें सही हो गया है गूगल, और they are doing much better today. But हमें डोमेन नॉलेज देना पड़ेगा। Every domain has a different meaning, right? जैसे भी हम आगे बात करेंगे, sentences mean differently in different domains. जब हम आपसे बातें करते हैं तो हम एक विशेष डोमेन में रहते हैं, और आपको पता होता है अभी ये इस डोमेन में है, अचानक आपने डोमेन स्विच कर दिया तो सामने वाले को दिक्कत होगी स्विच करने में कि अचानक क्या बोल रहे हैं। So therefore domain is very important, and legal domain की मैं विशेष रूप से बात करना चाहता हूँ। legal domain में, कि legal domain की बात करें हम तो there are so many sub domains of legal domain, जैसे इंटरनेशनल लॉ है, क्रिमिनल लॉ है, साइबर लॉ, प्राइवेट लॉ, रिलीजनल लॉ, so many things, and we have to create a data set in that domain. अब जुडिशरी जो भारत में है इस प्रॉब्लम में फंसी है कि यदि टेक्नोलॉजी नहीं है, there is no technology, and without technology we are not able to process cases faster, and therefore it's causing a lot of pendency in courts. So 1 Supreme Court, 25 High Courts, and 672 district courts. Look at the pendency, 3.5 crore cases pending in our judiciary. कैसे, how can we be successful? We cannot humanly tackle all that. हमें टेक्नोलॉजी चाहिए। 30,000 केस हर दिन फाइल होते हैं, 28,000 सुन पाते हैं हम लोग, 2,000 हर दिन पेंडिंग पे जाता है, जो बढ़ता जाता है। इनमें से 86% are pending in district courts. The less cases pending in high courts and Supreme Court, more pending in district courts, because diversity of regional languages. सारे केसेस रीजनल लैंग्वेज में आते हैं, उसको टाइपिंग करने की व्यवस्था नहीं है, फिजिकल मीडिया में आता है, एंड देन यू नो जजेस को प्रॉब्लम भी होती है, कई बार भाषाओं में इश्यूज भी हैं। करंट सिचुएशन देखिए, लॉट ऑफ पेंडेंसी, आई हैव डेटा टिल 2018, इट रोज बाय 8.6%, हाई कोर्ट्स 43 lakhs, एंड 2019 तक देखिए 58,000 केसेस वर पेंडिंग इन सुप्रीम कोर्ट itself. What is judiciary? You know, diverse society, huge population, massive number of cases, poor infrastructure, of course, technology support, poor, no, very, very poor. Pendency, back and forth, of course, बहुत सारी चीजें हैं. फिर मैं गवर्नमेंट ने ई कोड का एक चलाया हुआ है मुहिम, आप देखें ई कोड का, बट डेटा की जो कैप्चरिंग है बहुत डिफिकल्ट है। अब एफआईआर एक लॉन्च होती है, एफआईआर को लॉन्च होता है पुलिस स्टेशन पे, एफआईआर जो महिला आती है मान लीजिए, उसने अपनी भाषा में कहा, अब पुलिस वाले ने उसको हिंदी में लिख दिया, ठीक है, और उससे अंगूठा लगवा लिया। उसके बाद जो लिखा है हिंदी में पुलिस वाले ने, उसके आधार पर वो एक्ट लगाता है, फिर वो केस बनता है, फिर इन्वेस्टिगेशन होती है, फिर कभी कोर्ट में आएगा। तो ये सारा कैप्चर करना पड़ेगा आपको एंड टू एंड, नहीं तो थिंग्स विल बी वेरी वेरी डिफिकल्ट। डेटा देखिए, डेटा कुड बी हैंड रिटन, मल्टीलिंगुअल हो सकता है, मल्टीस्क्रिप्ट हो सकता है, स्कैन्ड हो सकता है, टाइप रिटन हो सकता है, डिजिटल हो सकता है। इफ डेटा, इवन इफ डेटा इज डिजिटल, द चांस ऑफ एरर्स, कॉपीराइट इश्यू, बहुत सारी बातें हैं। कन्वर्टिंग ऑल दिस डेटा टू मशीन रीडेबल फॉर्मेट इज डिफिकल्ट, मुश्किल है उसको करना। और उस पर डेटा को प्रिपेयर करना, मेटा डेटा डालना, सारी बातें करनी पड़ेगी, स्टैंडर्ड्स को वाइज करना पड़ेगा। अब डेटा प्लेटफॉर्म्स हैं, शेयरिंग है, उनको आप यूज करना चाहिए। क्रिएटिंग एन इंटीग्रेटेड प्लेटफॉर्म विद डेटा क्रिएटिंग एंड शेयरिंग फैसिलिटी, हमें इस देश में करना क्या चाहिए, दैट वन बॉडी डूइंग द डेटा क्रिएशन एक्टिविटी ऑन द ऑल द टाइम। देयर आर बॉडी, जैसे कि वैज्ञानिक तकनीकी शब्दावली आयोग है, वो डिक्शनरी बनाती है 24/7, लेकिन हमें रिसोर्स बनाना है, कॉर्पोरा बनाना है, यू नो, सारी भारतीय भाषाओं के लिए। So we had this platform ILCI, इसको दिखाएंगे आपको, Indian Language Corporate Initiative Platform. I'll show you that. And data sharing has to be there. If I create data, why don't I share? क्योंकि data might be, you know, proprietary और मेरे bread and butter से linked हो सकता है। When I do consultancy with some companies, they make me sign on NDA कि data एक साल तक data release नहीं करेंगे यार, उसके बाद release कर सकते हैं यार, because एक साल तक उसका data का फायदा उठा लेंगे वो। तो data sharing की बात होनी चाहिए। And then cost would be handled by, you know, bargaining some matching data in return. Just say I was consulting for LDC, University of Pennsylvania. They have a very good practice in place. You build data and then you exchange data. I give you my data, you give me your data. Then we can, you know, exchange. उसके बाद when I create data, I also would like to customize it. So if I have data, I give it to you, you use it and you give me customized data. You add, make additions to it, give it back to me. So ये सब चीजें करनी पड़ेंगी. You know, startup companies हमारे देश में कर रही हैं चीजें. I had several meetings with startup companies. In fact, I have my own startup company. You know, जेनी से निकी है. So it's a very complex network. We had meetings in Niti Aayog and we discussed, you know, that we should create a Section 8 company. कैसे करें इसको? अब डेटा भी जो है फ्री भी है, ओपन सोर्स भी है, पेड भी है, all of that. Manual, like you submit to some people, like GitHub, or automatic. You can have automatic data exchange mechanism. Like my tool can exchange data with, say, Typecraft in Norwegian University, or, you know, or IMAGACT in Florence University. So we can have processes where tools talk to each other. And for example, my tool has done 3 tiers of annotation. Then it goes to Typecraft, they add 1 tier of annotation, they send it back, then it goes to IMAGACT of Florence University, they do verb annotation for action verbs for robots. So all these can be done automatically, you know, across platforms. You know, unless that happens, you can't do any AI actually. You know. Possible models to emulate European Language Resource Association, ELRA एक बहुत बड़ा मॉडल है, और Linguistic Data Consortium यूनिवर्सिटी पेंसिल्वेनिया का है, हमारा ILCI JNU का प्लेटफॉर्म है. And how to go about data business consortium of stakeholders करना पड़ेगा. Prioritize data needs, क्या चाहिए डेटा आपको, क्या AI करना, जैसे भी हमें मान लीजिए कि सारी भारतीय भाषाओं में मशीन ट्रांसलेशन करना है to make sure NEP is implemented. So we have to have parallel data across languages. इंग्लिश में लेक्चर बनना है और वो लेक्चर सारी भाषाओं में अनुवाद होना है, तो हमें मशीन ट्रांसलेशन चाहिए इंग्लिश से सारी भाषाओं में. So we need English to Santhali, English to Bodo, parallel corpora. So the machines can be taught how to translate automatically. So we have to know which kind of data we need. And then we identify a team of creators, academia, industry mein, or then of course we can go limited cloud model, and then tasks of getting the guidelines, etc., done by this team, etc., etc. It's a whole big process that we have to follow. starting from the standards, how to create data, copyright, etc., and identify the team, and then create data. After data is created, you submit data to different teams for using, in XML format, etc. Funds कहाँ से आएंगे? Contributions from stakeholders. Model of ELRA LDC है. Basically, they get contributions from stakeholders. Registrations भी कराती हैं वो लोग. And membership fees भी होती हैं. Data company can be created. Section 8 company, as I said, can be done, which would be basically a non-profit company to create data from stakeholders and then distribute data to stakeholders. And revenue generation can be also done by marketing data. अब जो इंडियन लैंग्वेज कॉर्पोरेट इनिशिएटिव है जेएनयू का, ये क्या है इसके बारे में बात करना चाहता हूँ. It was a parallel and monolingual corpora in 17 Indian languages, fund given by the Ministry of IT of Government of India, and we created 100,000 sentences in all Indian languages, 17 Indian languages. 100,000 sentences tagged at 2 levels, part of speech and chunked on a server. So we finished all that, and I will be Hindi was the source language, and there were 16 other languages that we created. अब इसमें हम बताएंगे कि now what we have done in JNU in these areas. So we've done machine translation. For that we needed basically rule-based machine translation. Sanskrit से हिंदी में कैसे अनुवाद करना है. So we mapped the grammars of both the languages and dictionaries of both the languages to do it, and that wasn't very successful actually. Sanskrit से हिंदी. And the shallow parser tools that we did for 12 languages, including, of course, many languages of North and South with Hyderabad University. And this Indian language corporate platform, I will give a demo of that platform. And then the consultancies, currently I'm consulting Google for doing language variation studies. So if I'm giving a text to Google, can machine identify standard Hindi versus non-standard? अब नॉन स्टैंडर्ड हिंदी में जैसे कि भोजपुरी बोलने वाले हरियाणवी बोलने वाले कैसे बोलेंगे. So that kind of we capture the extents and specialized lexical usage of these people, these populations. So all of that, and last year we did again the bilingualism study for the same company. Federated keyboard for Kashmiri, Devanagari, nuanced technology के लिए किया था 2016 में. And a mobile keyboard Swift key के लिए in these languages, 5 languages, and this keyboard can be downloaded from Google Play Store and can be used by enabling these languages. It very quickly predicts the words. And how did we collect corpora for predictive keyboard? We had to scan internet to collect corpora, and then we annotate it, and then we run algorithms to train machine. There was a panel discussion with Chetan Bhagat on this. I'm not looking at that. And then online handwriting recognition funded by Microsoft 2006 for Devanagari recognition on tablet PC. Multimodal data in 8 languages for University of Pennsylvania. Basically, if speakers of these languages, Hindi, English, Urdu, Tamil, Bangla, Punjabi, Pashto, Dari, if these speakers cross some sensitive installations in the United States and speak in these languages, machines can flag them as belonging to some country. Because machine will be able to know कि ये उस देश के रहने वाले हैं भाषा से. Multimodal project. Then English to Urdu machine translation of Bing is done by our group. So if you click, you can see internet है इसको. If you click, then you can select English in this and Urdu, the target language. You see the name of our group. So you can go to bing.com translator and select English as source language or this target language. I get selected. अच्छा, अब यहाँ पे इंग्लिश चुनिए. टारगेट उर्दू चुनिए, उर्दू दाएं तरफ उर्दू चुनिए, दाएं तरफ राइट वाले उर्दू चुनिए. ये 2 बड़े ट्रांसलेटर हैं गूगल का और बिंग का. गूगल ने 13 भाषाएं की भारत की और बिंग ने 12 भाषाएं की. 12 में जो उर्दू है वो हमारे ग्रुप पे किया हुआ यहाँ पे. सबसे नीचे उर्दू होगा मेरे ख्याल से, यू से होगा. स्क्रॉल ऑल द वे डाउन. देयर यू गो. ये उर्दू ऊपर नीचे. You do that. क्लिक कीजिए उसको, नीचे नीचे आइए, चाइनीज में क्या है, इंग्लिश सेलेक्ट कीजिए, इंग्लिश पहले बैच, पहले वाले इसमें, हाँ इंग्लिश 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 नहीं, तीसरी चाइनीज आएगा बाय डिफॉल्ट, या यू सेलेक्टेड ऑलरेडी, you should scroll down, you should see a link to JNU. No? तो क्लिक कीजिए, चाइनीज में क्या लिखा हुआ है, यही होगा, इसको क्लिक कीजिए, हाँ ये क्लिक कीजिए, JNU, तो चाइनीज में दे रखा है उसको. When you click that, then you go see the so with JNU we were able to do it in Sanskrit school. और हमने इसको 2013 में लॉन्च किया था. इस वक्त बहुत अच्छा नहीं था ये इसका उर्दू का अनुवाद, but gradually it picked up and learned with a lot of community participation. Learned. Can you go back to the PPT again? All tabs will be back there. PPT आ जाएगी. PPT. Okay. You can go to the PPT, which is PPT already slide mode. Okay. Good. Now we have our tools which you can use to quickly crawl data, and not only crawl data but sanitize also, and also create frequency dictionaries of unique words in your language. यदि मान किसी भाषा में डेटा नहीं है मशीन लर्निंग के लिए बनाना चाहते हैं आप, बट यू नो कि इंटरनेट पे रिकॉर्ड्स हैं, रिसोर्सेज हैं, तो आप वो URL दे दीजिए, machine will quickly crawl data in bulk and then also sanitize and create frequency dictionary of unique words, which is good to go, you know. And this is our technology. We have Sanskrit, we have this servers, Pani Patanjali Katya and Bhartri Nagesh Bhatt, and we have a limited cloud model for large consortia-based development here. And then we showcase our resources every 2 years. अभी जून में हम फ्रांस में showcase करेंगे इस data को. And all of these events are sponsored by Microsoft Research partially, ताकि अपने students को वहाँ ले जा सके हम सेमिनार में participate करने के लिए. अब इसको क्लिक कर दीजिए एक बार. तो ये प्लेटफॉर्म में अलग लॉग इन यहाँ पर, क्योंकि मेरे लैपटॉप में तो वो पासवर्ड था यहाँ पे अलग. इसमें क्या है, कैन यू क्लिक ऑन द लैंग्वेज वाला, नीचे क्लिक कीजिए. तो सारे लैंग्वेज में आप बना सकते हैं रिसोर्सेज. इफ आई हैड माय लैपटॉप, बिकॉज वो पासवर्ड वो पहले से लिखा हुआ आता है, आई कैन जस्ट क्लिक पासवर्ड एंड ज्वाइन. So when you log in here, you see an interface where you click on one of the 18 domains. जो 18 डोमेन है उसमें से आप जैसे कि स्पोर्ट्स है, लिटरेचर है, आप उसमें क्लिक करें, उसके बाद then it takes you to an interface, आप डेटा बना सकते हो. जब डेटा बनाते हैं, the data goes to, for example, I had 17 partners. Like ISI Kolkata was for our Bengali partner data. IIT Mumbai was for Marathi data. IITM Trivandrum was for Malayalam data, like that. So we create Hindi data from JNU, and that data flashes to all the partners, and then they start translating the data. They start translating, and in translation, the server gives help, limited help, so that is to speed up translation, machine translation. And it partly builds data set also. उसके बाद then they start tagging it. Tag करने में there's help, and after the linguist tags the data or translates the data, data goes to chief linguist. Chief linguist can validate it or send it back to the linguist. After the data is validated by chief linguist, it goes to the PI of the group. So I was the super admin, and then
tell me what the cost of this? It comes out to be. You think a common man can pay 13 lakhs per day? See, I am not considering his father, his mother, himself. I just consider nature. The action he is consuming. 13 lakhs per day. What are the clothes and everything, food, etc. A common man, what are the common man? Which person cannot afford this? 13 lakhs per day. Can you afford? Now tell me what are the responsibility for this achievements? Okay. So now tell me, who are the computer for this type? Yeah? Not only nature, everything, including nature. His parents, not only parents, जो उसके सोसाइटी में रहते हैं, जो उसके फ्रेंड्स हैं, आप भी हो सकते हैं जाके. Because nature is spending 30 lakhs per day. Normal case. पर फिर भी कहते हैं हमारे कुछ किया ही नहीं. हमारे लिए कुछ किया ही नहीं. फिर मैंने कंसीडर होता क्या है, एक पेड़ खड़ा हुआ है, अगर मेरी गाड़ी का पार्ट हो जाए, पार्ट नहीं इसे. ये परिणाम लोग बड़े कॉमन है. ये ट्राई किया, मेरी गाड़ी पार्क होनी चाहिए. You cannot see this 30 lakhs per day. अब तो ज्यादा हो रही है तो 2 लाख की बात है. Energy of plastic. I will there to cut next type. Mental, physical. Not खाते पीते हैं डायरेक्ट physical. Mental, जो thoughts हम सोचते हैं, हमारे पास आते हैं thoughts. So food for A, what we eat, think, yeah? Yes? It has already contaminated to a good extent. I think I was laughing. That's what due to the contamination has created health-related issues. You agree? As a result, has affected our mental appetite or mental power. कैसे खाए आज? Good. Food for me. What we think in experience act. All are the food for the mental appetite. It is no less than the physical food. आप किसी को फूड दे रही है और उसका मेंटल स्टेट ठीक नहीं है तो फायदा नहीं. You agree? Yes, sir. Very good. Tell me. क्वेश्चन पढ़िए. बताइए. Simple question. क्या? Simple question. Tell me. कुछ करने की जरूरत नहीं है. कुछ करने की जरूरत नहीं है. आंसर इज कुछ नहीं करने की जरूरत. उसको खाली छोड़ दीजिए. बस उससे कोई बात कीजिए, उसको काम दीजिए. वो पागल हो जाएगा, आप लोगों को पागल कर देगा. Yes, no. और बहुत से रेस्पॉन्स. So we have changed our likes and dislikes. In fact, our feeling and thinking also. Do you agree? I will show you. Hardly pinches in our heart if any human act is done to someone who is not near dear to us. Do you agree? Yes. This child was spread to get the kidney. For the distributor. I will tell you one simple example. In Ghaziabad, there was a surgeon. क्या करता है वो सर्जन? क्या करता है? जी का काम करता है ना. He got many awards. मालूम है क्या करता है? रेगुलर में लोगों को मतलब कुछ लोग थे, बैंक था एक, ले जाता था, वो भीख मांगते रहते हैं, पढ़ाई करते हैं, ताकि ये भीख मांगने के प्रोसेस. This scientist, doctor, जिसको कितने अवार्ड मिले थे, कितने गुड हो गए हम. Don't you feel like that? Only for the kidney he was killed. See this. That created two types of plastic. Intact plastic, of course, intact plastic. When we do not feel the pain for others, one or near to us, it is intercluster. But the problem, when the boundary line between the clusters, between two family members, not family members, between two families, becomes thick or broad, it leads to classes like moving rights. Yeah? It is spoils the fabric of the society, creating various types of problems. Is it also mattering in the family? Like that? When we do not feel the pain for near and dears, अभी तो दूसरी बात चल रही थी, अपने के लिए भी नहीं है, भाई का मैटर कर देता, नहीं, कैसे करिए? When the boundary line among the member of the cluster, एक family के दो member के बीच boundary line, it gives the place like family classes, husband wife classes, father son classes. It is called the fabric of the family. Family fabric of social, resulting very strong like Java's family populations. Yeah, they are another problem, which is called bad mood problem. Bad mood means single person किसी से बात नहीं करता, ना उससे कोई बात करना चाहता, and then what the problem? ना वो किसी से बात करना चाहता, उससे कोई बात करना चाहता, so that is called bad mood problem. That's one problem. In this problem, either that person does not allow anyone to join with him. No person wants to get into this lecture, or no one like to join him, and this lead to the suicidal situation. भाई कभी करेगा तो अकेला रहेगा, तो फैमिली में रहेगा, किसी से मिलकर रहेगा, बिल्कुल नहीं करेगा. And this is one of the problem question. And this is social aspect, no technical aspect. Real life का आते हैं. अभी तुम्हें नाम की बात करेंगे. Just observe it, feel it. Feel it. Now tell me what the next slide. What the next slide can tell me? I will repeat it. Observe it. Now tell me what's the next slide? What? I did not get. Huh? What can be the next slide? Sorry, I did not get. Huh? बोलो, मुझे सुनाई है? हाँ? हाँ? नहीं. Serious, sincerely. Now I will tell a story. Both of them are IAS. You know IAS? Highest position or lucrative job. पैसे कोई कमी? रुपये की कोई कमी? शोहरत कोई कमी? कोई सर्वेंट की कमी? किसी की कोई कमी? वेरी गुड. ये बच्चा है, नेचुरली इतने लोग होंगे तो ये इन्होंने रख लिया आंटी को बच्चे की देखभाल के लिए. नेचुरल है, नेचुरल है. कुछ चारों के लिए प्लास्टिक की गाड़ी है, सब लगा बच्चा बड़ा हो जाता. आंटी थोड़ा इसके हिसाब से गरीब परिवार से है तो आप समझ सकते हैं. This boy does not go to his parents. He goes to his. Right? And this boy does not go to his parents. They are IAS. Because वो समझते कि पैसा दे दिया बच्चा अपने आप कर जाएगा. They did not get the time. किसी के कहाँ आएगा? This is the real mother time. Yes, no. Yes. This is the practical exam time करें. And this fellow I think टीचर है कि नहीं है बनाया हुआ लाइफ का. मैं अपनी पढ़ाई कर रहा हूँ. ये रियल कहानी बता रहा हूँ मैं, आप ऐसा नहीं है कि वैसे बना दिया मैंने. This fellow does not go to his parents. उनके पास जाता. What my reason I बहुत रिच है ना, ये बहुत रिच है ना, खाने की रोटी नहीं, आप समझ सकते हैं ना। बड़ा क्वेश्चन, पानी पिला दे भाई, पानी पीना थोड़ा सा, क्योंकि जब तक इसको घुसाएंगे नहीं आपको इंटरेस्ट नहीं आएगा। हाँ टेल मी, बोलो, why the high cost for the good things? कैसे करके बताओ, रफी बता दो। Can you see? There is one car on the road. There are two cars. Now let us see this. Green car drives safely, white drive wrongly. There is possible accident. Hello. If G drive means green car drive wrongly and white drive safely. Yellow. There is possible accident. If no drive wrongly, there is possible accident. There is only one possibility when both are safe. Out of 4 possibilities, there is only one possibility for the safe. That's the possibility. Yeah? No? Accident occurs only when one car enters the cluster zone of other. Have you done accident? Accident may also occur if there is some issue with the car, like एक खराब हो गया, कुछ हो गया, there is an inter-cluster problem. आप देखिए इस बार मेंटल कन्विक्शन समझते हैं ना, आप किस चीज को कितनी कन्विक्शन के साथ करते हैं, मतलब कन्विक्शन, क्या you know this fellow? Hello, is Air Marshal Arjun Singh. Last 10 years you want to reach here. Last 10 years. पिछले 10 साल से अभी तो है नहीं है, एक्सपायर हो गए। जब थे last 10 years you are on the wheelchair. One of the very senior officer of the Air Force, even most helper मिली होते हैं। You see, the person who is on the wheelchair for last 10 years. अब्दुल कलाम वो अपनी खुद चेयर से उठे हैं, वो 10 साल से आते व्हील चेयर पर है, लेकिन चेयर से उठे हैं तो सपोर्ट के लिए उन्होंने पकड़ा हुआ है, but he is not the physical power, I don't understand this. Can you see this fellow? See this. He's the captain in Jammu Kashmir. Both the hands were amputated. मशीन होगी, आराम मशीन उसमें। See this कैसे बॉलिंग करता है, देखें? See this. He's the captain. और भी पसंद नहीं है आप इसमें। Can you see this? बड़े टेंशन में है, right? See why? Internal force, मन की जो ताकत है, मानसिक करंसी है, वो काफी कम है, इसलिए टेंशन में ऊपर। इंटरनल फोर्स इज less than the external force. बाहर की चीजों ने बहुत बढ़ाया हुआ, समझ नहीं पाता। दूसरे केस में एक्सटर्नल फोर्स इज लेस, अपनी मर्जी से करना। लेट अस सी। हेलो, यस सर, गुड। टेस्टिंग बता रहा हूं मैं आपको। When one desire is a kind of internal force, becomes very strong to take on everything. It needs to चीजें मतलब मुझे चाहिए सब चीज, इतनी हो गया मैंने, मुझे सब चीज चाहिए। पर्सन उससे क्या होगा? It creates the imbalance between the intra force and inter force. It is a disparity in the society. आजकल सोसाइटी में यही हो रहा है, किसी के पास खाने की रोटी नहीं है, इंडिया में पैसे की या किसी की कोई नहीं है, ओनली मिसमैनेजमेंट, डिस्पैरिटी, दैट्स ऑल। हाँ बताइए क्वेश्चन कहाँ से दीजिए। बताइए। There is only two answers, yes and no. Yeah? No, tell me. Hello? Yes and no? मुझे न्याय मुझे कुछ लोग बोल रहे हैं, कुछ गलत बोल रहे हैं। हाँ? Yeah? Yes. ह्यूमन वेस्ट को आप ब्लॉक कर दीजिए, क्या होगा? बॉडी के अंदर ह्यूमन वेस्ट को ब्लॉक कर दीजिए, क्या होगा? वेस्ट को सही पूरा मानते हैं ना, ह्यूमन वेस्ट को, इसको बॉडी के अंदर ब्लॉक कर दीजिए, क्या होगा? हेलो, आपके आंसर का दे रहा हूँ, जो आपने बताया यस, क्या होगा? उसको परेशान होगा या होगी, पूरे परिवार को करेगा परेशान, डॉक्टर के पास जाएंगे, अब उसके बाद बचे या ना बचे उसको पता नहीं, राइट? तो bad things would be channelized accordingly. कैसे नहीं, आपने पॉइंट ब्लैंक ब्लॉक कर दिया है, क्लियर? अभी और देता हूँ एक और एग्जांपल, कैन सी इट? व्हाट इज दिस? This is the very first party may say in the world itself, March 1872. इसमें काफी तरह के जानवर थे, भेड़िया भी थे, भेड़िया समझते हैं ना? हिरन भी थे, रेंडियर, वो बारहसिंगा भी थे, और भी थे। कुछ दूरी पे इनके रेजिडेंशियल एरिया था, तो कभी कभी ये भेड़िया वहां चले जाते थे, बच्चों को या बुजुर्गों को या भी नुकसान कर देते थे। तो बताइए ये पर्सन क्या करेगा? हेलो हेलो, उन लोगों ने कंप्लेंट किया तो भेड़िया तो सब मार दिए गए, क्या ये तो ओनली ऑप्शन? उसके बाद क्या होगा बताइए? हेलो, उसके बाद क्या हुआ? उसके बाद एक डेथ हो गया भाई, क्योंकि जो दूसरे एनिमल थे जिनको भेड़िया खाते थे उनकी पॉपुलेशन बहुत फ्रैक्चर्ड हो गई, तो उन्होंने सब ग्रीनिश सब खा लिया, डेथ हो गया। भेड़िया को बुरा मानते हैं कि नुकसान करता है ना, भाई इधर ही मिल गया, आपको कुछ कर देना चाहिए, क्या चाहिए? तो हाँ चलो नहीं, I will tell you one simple thing. Let us say I am assistant professor, ठीक है? तो असिस्टेंट प्रोफेसर को मैं जीरो समझूंगा, क्योंकि मुझे तो एसोसिएट बनना है ना, जबकि असिस्टेंट के लिए बहुत से लोग कोशिश कर रहे होंगे कि उन्हें मिल जाए, राइट? तो व्हाटएवर वन पर्सन गेट्स इट, assume or she assume it is at zero level. Do you agree or not? Hello? Very good. As the age grows, the person loses his or her strength, of course, physical strength also. Yes? Which is nothing but an inter-cluster force or mental power. Yes? If there is a need to have some external input to maintain oneself, it can only be provided by the environment, especially the home environment in which he or she lives, not by any other way, be it money, be it house, or any other. Do you think it? Very good. Then how it will help the younger generation? And यार अभी आनंद आ रहा कहानी, अब बोलिए, तो थोड़ी देर में बोल दीजिए, मैं कोशिश करूंगा जल्दी से खत्म हो जाए, लेकिन अगर जो खराब हो गया तो फिर ठीक है? Tell me one question. Question थोड़ा सोच करिए। How does it help the younger generation? अब देखिए कैसे करता, क्योंकि उन्होंने बोल दिया था। It certainly has, but unfortunately we are ignorant or we are egoistic. हम अपने पेरेंट्स को गांव में इसलिए बोलते हैं कि अनपढ़ हैं, हमारे कोई पढ़ा लिखा आएगा तुम्हारे फादर तो अनपढ़ है ना, हाँ सी वो
ये नहीं समझता कि उन्होंने हमें जन्म दिया। यस, कंसीडर किया, मैंने आपको बताया था, if person consider anything after achieving as zero, which of course may be came for many, जिनको मिला नहीं है वो, and one for the parent as they have seen their long life, what that means, ठीक है? अब देखिए क्या होता है, when we combine 0 and 1 in different ways depending on the importance of the given, अपने आप को इम्पोर्टेंस देना है या पेरेंट्स को देना है, उससे देखिए क्या होता है, giving the more importance to self, putting first self and the parent, it leads to a 0 बनना, 0 से तो बढ़ेगी ना ज्यादा पावर, it has added some value as parents have been made to associate, parents अभी साथ हैं, रेस्पेक्ट करता नहीं करता, that is different issue, अभी साथ है केवल, giving more importance to the parent, placing the parent at first, can you see the value? इसकी वैल्यू कैसी तो ओरिजिनल 0 कितनी हो गई, आपकी वैल्यू कितनी बढ़ गई है, 10 होगी 0 से, हम आपको 10 ध्यान नहीं देंगे क्या, it has increased your value tremendously, 0 से 10 कर दिया, यस, बताइए, it is a name or common name for question, belongingness, अपनापन, you know this fellow, you know not know, of course he is Indian, you are Indian, we got the Nobel Prize, chemistry, we getting Nobel Prize. नोबेल प्राइज तो अच्छा होता है ना, अच्छा होता है, बहुत अच्छा होता है, बेस्ट होता है वर्ल्ड में, एंड ही इज गेटिंग, तो ये सुन लिए थोड़ा आना चाहिए ना, टाइट आना चाहिए ना, यस नो, टाइट आएगा नहीं आएगा, क्योंकि इस बंदे ने ऐसी बात कह दी है कि आपको लगेगा इससे तो मजा आता है, क्या बोलता है ये कहता है, आई वाज रॉन्गली बोर्न इन इंडिया, I was wrongly born in India. इसका मतलब क्या, आपके पेरेंट्स को गाइड दे रहा है ना, क्या, इसलिए you have respect for him, Nobel laureate, हेलो, मेरे ख्याल से पसंद करना चाहिए, आज तो हम ये, अगर कुछ है अगर कोई क्वेश्चन कमेंट है तो आप डिस्कस कर सकते हैं, मैंने आपको बहुत कॉमन चीज बताई है प्रैक्टिकल लाइफ की, अगर आपको कुछ डिस्कस करना है हाँ, हो गया मेरा काम, अगर किसी का कोई कमेंट थॉट है तो बताइए, क्या मैंने इनको कोई टेक्निकल चीज नहीं बताई, टेक्निकल नहीं ना, लेकिन काम की बताई है, उम्मीद है 2-4% तो समझेंगे इसे, ये काम हो जाएगा, इतने लोग समझिए ना, मैं पहली क्लास में जब पढ़ाने जाता हूँ पहले यही सिखाता हूँ, उसमें 2-4 लोग होते हैं जिनको इंटरेस्ट करता है, तो बीच में कॉन्टेक्ट करते रहते हैं, इसका मतलब राइट, मेहनत सफल होती है, वरना तो सब लोग पढ़ाते रहते हैं, हम भी पढ़ाते रहते हैं, आप लोग भी पढ़ाएंगे अगर टीचर बन गए तो कुछ मालूम नहीं है।
Rightly said by Professor Satish Chand that most of the problems in real life needs approximate answers. Therefore, we need machine learning in daily life. Thank you, sir, for such an innovative session.
और तो काम हुई ना मेरा यार, ये तो निकालो भाई। दो में इतना होता है कि साथ चला जाता। Thank you,
of a IoT and its convergence in AI. Most of term artificial intelligence and IoT nowadays getting popularity with respect to job and its research ability. The question arises, can we do independent AI activities, or do we only concentrate in IoT, or at what stage we have a opportunity to do the convergence of AI and IoT? So in today's talk, I will try to discuss few application domains of the IoT and few domains of the AI, and then in the last I will show you one application area where we have implemented this convergence for the implementation and usage of a specific task. So now at this stage, we need to define two aspects. One is the artificial intelligence, and the second one is the IoT. And the convergence of these two areas will lead to artificial intelligence of field. When we start talking about the convergence, so basically it will give us the another area of the research or area of the application, which leads to development of a new domain, that is a AI of things. Another question is, what are the various application domains where we may introduce AI? So the few application domains are industrial, healthcare, agriculture. These are the few aspects. So when we talk about the industrial, what are the areas where people are looking towards the job opportunities in the industry sector? One of the very popular area is a security system. You must have read the article that the CCTV installation or fire alarm system, where we have a system of collecting the data through sensors, through the computation, and target to reach to some concluding remark. So when we start analyzing the data which are collected through the sensor, so the collection of the data through sensor is nothing but, we talk about, that is a part of the IoT. So IoT is nothing but gives us the different protocols, different media through which we can transmit the data and collect the data through various types of sensors. Then, and at the end, when we try to analyze those data, so one way to analyze those data is the statistical model, where simple analyzing can happen. Second technique which helps us to give the more fruitful discussion and fruitful concluding analysis, that we will try to collect the data place it in the knowledge repository system, that is our data server, and try to analyze with the help of various search and optimization techniques or various machine learning algorithms, or with the help of some sort of AI technique. So those techniques help us to read and to predict the consequences if the data or the trend of the data will go in a specific way. So until unless we will be able to predict the consequence of the data, that data cannot be a fruitful data. So the importance of the AI to converse with the IoT lies here. That to understand and to fetch the meaningful information. Until unless we fetch the meaningful information from the data set, that data or those collection of the data cannot be used. So that is why here we have a terminology that is called AI of things. These are the basic introduction of the AI and IoT, where we state that AI of things is the next key step of IoT, transforming the process of analyzing data and turning it into action. This is our key statement. This is the objective of our whole study, that until unless we do the fruitful analysis of the data, those data cannot be useful. So the fruitful analysis can happen and can be delivered only with the help of the implementation of the AI technique. That IoT will help with the new generation of AI enablement due to the aggregation nature of IoT. So aggregation of IoT, it means that IoT provide us the different platforms. Because whenever we talk about the IoT or industrial IoT, or we talk about the artificial of things, at the end, the IoT is nothing but it provides us the platform where there is a hardware, and on top of it, that hardware allows us to deploy customized software. The customization of the software is very important in the IoT domain. And the second important component is that the applications which are developed over this platform, those applications can be developed with the help of the open source technology. So these two components are very much important when we are talking about the IoT applications or IoT design domain. Because in IoT, where basically IoT provides us the framework. If you are implementing the fire alarm system, if you people have ever studied normal digital electronic system, then you will also find there is a mechanism of fire alarm, that you just put one sensor, the sensor which can detect the smoke, and that smoke can be connected with some relay switches, and it will allow us to generate some sort of a bell system. That is a trivial system to generate the fire alarm. But when we talk about the complex fire alarm, complex in the sense we have in one building we have 8 to 10 lifts are available, escalators are available, so many labs are available. Now in those cases we need to put each and every sensor with a specific address notice. We can't put the address sensor just like that. It means the sensor must have a capability to access the address LAN network system. It means that you are incorporating a LAN addressing mechanism with the sensor. Then only you will be able to recognize that where this sensor is placed. Number one. Number two, if you are aggregating so many number of sensors at one place, it means that you are using some sort of a controller. So in a large system, that is a big controller. In a small system, it is a small microcontroller. So we must have a knowledge of a microcontroller system. So one of the most popular microcontroller nowadays we are using are based on the Arduino processors or Raspberry Pi. These are the two popular microcontrollers which are available in the market for the development of the IoT based applications. Why these two are popular? Because this will allow us to do the development, to allow us to develop the application with the help of the open source technology, whether it's an Android based technology or it's a Python based technology. So this is a very important part, because unless you will be allowed to develop your application over this platform, and if that technology will not allow you, then you cannot write appropriate application through which you will be able to implement your own algorithm. So these are the two important parameters to understand that how do we aggregate various IoT sensors, and if this is permitted, if this is possible, then only you will be able to communicate with your hardware with the internet enabled devices, because at the end the final solution will not be stayed here. The final solution will appear only if you will be able to upload your data on the cloud, because then only you will be able to state that you have developed a appropriate IoT enabled framework. It means that we needed appropriate communication protocol, which should be the inbuilt facility of the microcontroller. So all these things are the important parts in the aggregation nature of IoT. The third one is, at its core, IoT is gathering massive amounts of data, and as the data is processed through the data and the algorithm of that, the analytical and action part of IoT will get. So this is what I said, because this type of a system, when you are developing a hardware system where you are connecting so many number of sensors, is that the data gathering capability of that is enhanced. You need a high-end solution to process those data sets, and that data cannot be processed on the core of the chip itself, because the microcontroller has a limited facility of the computation, whether you are using Arduino processor or Raspberry Pi, whatever the model you are using, because ultimately all these both the processors are based on the ARM architecture. That architecture does not allow us to load operating system over this platform. Otherwise, the capability to capture the data will be reduced. So that is not the objective of this microcontroller. So we are uploading those data on the cloud, and on the cloud we will place AI algorithm to do the computation parts and analysis parts. So, key driver of this convergence is to overlap of IT and operational technology groups, driven largely by the digital transformation and significant gray space, the common technology between each area. Now, here we should understand that how do we decide that where AI plays the role, where IoT plays the role, and the third terminology we are using is the operational technology. Operational technology is not a technique where we are using, but to implement any framework, we must have a appropriate domain. So that domain plays an important role to converge this IoT and AI. So in this is the very important diagram which states that how do you relate the data science and AI, and where is the IT software and where is the operational technology. So you can see, if you see the data science and AI domain, then you find that few important terms like neural networks, deep learning, machine learning, decision tree, and random forest. These are the basically machine learning algorithms. So we are using some sort of machine learning algorithm or AI learning algorithm to analyze the data sets, and those data are normally being collected with the help of some sort of a IoT enable architecture like cloud, simulation. So those things and the operational technology help us to get the domain expertise of this area where we will have a proper data. You can see another thing that data analytics, because data analytics is again, once you have a data set and when you have a automatic capturing capability of the data with the help of the IoT framework, so we must incorporate some sort of data analytics if the analysis is linear. Understand that the AI algorithms are used when our objective is to get the non-linear outcome. When if you are expecting that there are multiple variables which is influencing the output, in those cases it is advisable to use the AI algorithm. But if you have a limited variable which influences the outcome, in that sense the statistical techniques are also sufficient to conclude the particular problem. So these are the few applications area which are popularly useful for the AI and IoT amalgamation. One of the most popular techniques is healthcare, and almost within in this class also I expect that minimum 20% people must have a that watch which measure all your physical routines. So it is nothing but it is a IoT enabled device. Depending on the device which you are using, few devices use so many number of parameters, few devices use less number of parameters, and that depends that what are the applications which they have developed. Because for each and every application there is a cost. Few devices, the people who are using the Apple Watch or Samsung Watch, they may have some sophisticated features because they may have some sort of a more complex AI algorithm. They may have given have a more complex multivariable convoluted grid. So this is the one application where people are very a large number of people are using this type of application. And nowadays, in fact, after Corona, this your oxygen oximeter is there. Then there is a machine which measures the sugar, blood pressure. These are the few machines nowadays. They are providing with the IoT enablement. IoT enablement means that internet enablement. So basically, that device has an IP address, and if the IP address is connected with the cloud and Wi-Fi enabled devices are there. So those devices help us, help the healthcare sector to monitor the live, to monitor this the patient live. So that is the advantage. Then one of the another application is the fleet management. This DHL or any other large big courier service, these people are using it because they have a barcode system. So whenever one package is being couriered, it is being tracked appropriately with the help of a tagging of that barcoding model, and that is being delivered with the help of the software. Then smart home. In fact, nowadays it is not a new term for us. Earlier there was a new term because nowadays many companies of fan, light, now they have started giving that mobile controlled fan, AC, because now all these devices now are coming with the this internet enabled chip. So if the devices is having an internet enabled chip, then it is possible to access with the help of the IP address, and the mobile app help us to control that device. Then this is the another area application of IoT in agriculture sector. So this is also becoming popular nowadays. But in our country, that popularity is not up to that level, which is available in US or Europe, because of the size of the farm and because of the population. These are the two important parameters. When we talk about the deployment of the drone monitoring model of a crop, so because in our country, one of the major aspect is the cost of the labor. the cost of the labor is very cheap. So if that cost, and second issue is that what is the area of that farm. So if you compare the area of farm in US or Australia, especially, so they have a large size of the farm. But, while in our country, except Punjab, you won't find size of the farm in a larger size. That is the one of the major constraints. But even though the people have started using these applications, because there is a multiple things where we can do this. One aspect is that monitoring of the crop, monitoring of the horticulture, especially in the season of if you follow any orchard like mango, where there is a large number of trees of mango, and if you wanted to monitor that what is the crop growth, so it is the best way to monitor with the help of the drone. But the question is, do we have an application available to capture the appropriate object? Number one. So for that we need to develop the application. The second one is that prediction of a disease at the early stages, because like the human being, if we changes our color, the color of the face will change, and we say that okay, there is some sort of disease. Similarly, in the plants also, if the color of the leaf changes, then it shows some sort of a disease. So based on that color, the system has a vision to predict the disease at the early stage. So this will prevent to grow that particular disease. So these are the various application domains where we can deploy. So this is the one application area where my team has worked. So this is the one application of IoT in agriculture sector. This is the project related to the prediction of a disease at the early stage. Here we have chosen to predict the disease, only 4 diseases of a tomato plant, and we have taken the help of the Indian Agriculture Research Institute, the Pusaru. So in this case, the 45 tomato pods have been established and in the greenhouse, and artificially they have inoculated the diseases. So when we have inoculated some diseases, then some sort of a that color of the image, the leaf will change. So basis on that color, we will get the help that how do we classify various diseases. Because in artificial intelligence or in any machine learning algorithm, the important part is the training. It's a machine. Understand that it is a machine, and you are capturing the data with the help of some sort of IoT or some sort of thing. But the machines are required to be trained. So the training is the important part. So that training, for the training purposes, you need to inoculate some sort of disease, and those diseases. Now the question is, how many number of images can be inoculated, and how many number of plants can be inoculated? There should be a limitation. You may not be able to cover all the cases. So for that, there are some techniques in the machine learning which help us to enhance the number of images. So that is, here we have an AI. Then the capturing of the data, that is the sensors. The sensors which we are using for capturing the disease-related environment, like what is the soil moisture, what is the environmental conditions. Because in any disease, when disease start grow, disease is related to the environment also. Because what is the temperature, then what is the humidity, what is the moisture. So those things shall be captured with the help of the deployment of sensors, and that is that sensors are required to be deployed here in this sensors. This is the same image. These are the various sensors, and these sensors are placed, and these sensors are being powered with the help of a solar, because it is remotely placed. So we need to have some sort of a power. So this power it is a solar cell operated sensors, and those sensors are inbuilt. They have an inbuilt communication module and this all the GSM or all these mobile service providers, they give us the one-way communication device SIM. That SIM can be placed in those microcontroller. So automatically the data shall be transferred to the cloud remotely with the help of the mobile communication system. So this is the advantage if you are deploying IoT environment at the remote location. Here we do not need any control mechanism, or we don't need to deploy a manpower to see that the data, that how the data are being captured, what is the data frequency. So in this type of environment, we have a facility to deploy and capture 24/7. So once we have a data set, we will be able to analyze with the help of various AI techniques. These are the few images of the early blight disease. So you can see it here. So this type of images have been captured. Now we have three types of data. One is the image data set, another is the sensor data set, and all these data sets, all these data are required to be related and required to be trained so that they give us the appropriate outcome on the unknown value. These are the one example where I will do. Again, as I told you that whenever we do the experiments, there is a limitation. Limitation in the sense that how many number of a plant you can place, the limitations to maintain the plant. So we have a very small number of data sets. But in any AI techniques or machine learning techniques, if we have a small data set, then it will not give the appropriate outcome. So to get the appropriate outcome, we need to use some sort of image processing technique to augment the data set. So there are some algorithms which are available for the augmentation of the data. So these are the techniques which we have used to enhance the number of images so that our data sets can be enhanced and we will be able to get the good training data. So in the same example, we have categorized that total number of 97 number of collected images are there, healthy images, and the early blight is a disease. So after augmentation, you can see now we have enhanced almost 5 times with the help of data augmentation techniques. So unless we will convert the techniques, various techniques, you will not be able to get the appropriate outcome. That is why convergence of the technologies are very important. If we think that only AI will be able to give us the appropriate, that is not done, and neither IoT is independently better, because IoT will not give us the techniques, will not give us the mechanism so that we can enhance the number of images. Our objective is to understand and train the system so that when we give us the unknown input, that system will deliver the appropriate outcome. That is the objective. To achieve this objective, we have enhanced it, and this is how we are getting it. So in this case, based on the visual inspection, we have taken the help of the expert, because this is the whenever as a computer science people we are working up with to develop a system for the agriculture or medical sciences, we need to take the help of the subject expert. So the subject expert have given us that suggested that these are the images we made for the blight disease, early blight, then middle stage of the early blight, then late stage of the early blight, depending on the visual inspection. So we have made the classification. So at this stage, once we have it, because before going into the training part of a machine learning or AI technique, you must have an appropriate data sets. Whether you are using simple machine learning algorithm, or you are using deep learning algorithm, or any of the CNN techniques, or any ready-made tool. At the end, we must have a. So this is the one application where the CNN has been implemented with the help of so many number of readily available CNN, like ResNet 50, ResNet 101, speed, and it gives us the appropriate result. But before reaching to this, we must design our experiment in such a way so that it will help us to develop the applications. Okay. So this is all about from my side, and any questions related to this? You are most welcome.
Today's business world is changing with the adoption of IoT.